Welcome to what we're calling our case study number 2. We're going to be covering real quick, we're going to talk about tracking, and even more importantly to the tracking, the integration of tracking footage in an architectural visualization pipeline. We have essentially three parts of this case study. The first part, we're going to do some tracking in a program called PFTrack. The second part, we're going to be doing some tracking in Nuke. And then the third part, we're going to be taking the data into 3D Studio Max and aligning information to show it. While I'm getting started, and Jeff, I know that some of this won't necessarily play, so I'm just going to show some real quick films of some of the shots that we've tracked. I'm actually going to turn the audio off. Some of our projects, we do this on a fairly regular basis, where we have aerial footage. I'd say that in a typical project in Neoscape, we do more aerial tracking than any other, but we do on some occasions track footage that we would shoot on a studio set or shoot from a car or shoot from the ground. So this project here was a Brooklyn project where we had quite a bit of footage, and you can see that not only did we track and place the building in there, it was pretty heavily treated. Both the building, it wasn't necessarily supposed to be photorealistic, it was supposed to draw your eye and really point things out. One of the things that is a common occurrence when you do track footage and match in aerial footage is if you do a good enough job, you can't even tell what the project is. So this one didn't even have, this one is not quite as motion graphics heavy as other versions of the same film. I know that this is going to be used in examples coming down the line. Of course, I grabbed examples that I'm familiar with, so I apologize if people notice that they're years and years old. But this is, I shouldn't be using VLC. Oh, it's a WMV.
If you go back to the tracking, go to the CG school. Case study 3 animated build.
Okay.
Examples. Exterior.
Here we go. This is the same project, and I will skip because I don't want to steal these guys' thunder when they talk about the animated builds, which are a common technique we use. You can see that this project had a significant amount of tracking in it. And this one was another one where one of the hardest things about tracking is actually not tracking, but when you do the integration, you often have to take out things. In this case, we had cranes all over the project, so we had to take them out of the backplate. So that's something we'll touch on too. Let me take you guys in, and so what I'm going to do is I'm going to jump right in to PFTrack and get us started. So we're running, PFTrack is one of those companies where they do update the software on a pretty regular basis. So I think we've got different, oh yeah, it's Farm, PFTrack. So we're on a version that's maybe a month old, but there's 2 versions since this 2.2. PFTrack is a specific tracking software. It comes out of a group called the Pixel Farm in the UK. They have a whole series of tracking suites from, there's something called PFHO, which is there's a newer version available, thank you. But the interesting thing that they did when they developed their software is that they've used the same engine for all of their software across it. How many of you guys, just as a quick survey, how many of you have done some 3D tracking sometimes? So I see maybe 10 hands go up. And has anyone used PF Track for it? No, not PF Track. So what are some, do people use Nuke or Synthesize? Yep, one hand there. Buju, a couple of hands. Match Mover from Autodesk, yep. So yeah, so the basic, and for anybody who's done more than more tracking in more than one software, it's pretty much the same process. At least now that there's sort of an automatic tracking. There were times in the distant past where you could do match moving if you did manual tracking of all of a footage. There was a feature in Max actually, and I know that Maya Live was based on the same idea. I'm just going to put this on this local computer for now. But nowadays, the sort of idea behind tracking is we use the same basic information is invalid model. This was the let's use wonder. But one of the things that when we approach a tracking project, or when we approach a project where we know there's going to be helicopter footage, we have sort of a couple of rules that we follow. In the previous demonstration, Seth was talking a lot about sort of, he has a very meticulous way of approaching some of that view match, and I'm sure that everybody here has done a lot of view matching, and you know that sometimes you can be precise, sometimes you just wing it, get close enough. It just really has to look right, and as long as some of the context matches, you're pretty much good. Unfortunately, when you do track, it has to be right for it to work. For anybody who's ever done tracking, you'll find that when you track and it's sort of, if there's a problem, it's very easy to see it. It's one of those things where, especially if it's something that's not smooth, if there's a bump and the matched in item doesn't bump at the same time the footage bumps or something, it's just totally broken. I mean, it's sort of one of those things where if it's not perfect, it's wrong, because it's one of those things where you can really tell when things don't work. So for this example, I'm going to quickly show, this is a shot of Central Park, a nice one-point sort of perspective. We've got a good horizon here. The footage has a lot of detail. We are going to show examples, again, of aerial footage that we've tracked. And so a lot of the settings that I use are specific to aerial footage. And when I've done footage of a moving camera on like a green screen studio, you'll see here on the wall we've got tracking markers. Those are the ones we would put on the wall behind if we're moving the camera. We do often use some different settings, and I'll just mention that real quick. But helicopter footage is really ideal candidate for tracking because there's so much information and there's lots of stuff to chew on. So it does make the tracking sort of a little more straightforward than some of the green screen footage. But one of the things that we do try to avoid, I mentioned having the sort of checklist in our mind, something we really do try to avoid is any zooming cameras. It can be done, and all the software will claim that it will track a zooming shot, but it's just not worth it. Very, very rarely is the shot so important that has a zoom in it that we will actually bother. Usually we just sort of throw those away right off the bat and just use ones where we know we have a fixed field of view because the tracking is so much easier. And I'm sure the people who've tracked have found this, but this is sort of my experience, and I think Matt and Vinny might agree. Tracking is a little bit of a black magic because sometimes you find footage that just tracks and it's perfect first try. You don't even have to do anything. And sometimes footage that seems like it has all of the same qualities is just a bear. And it could take, we might have a movie where we have 6 tracking shots, and 5 of them, you could bang out all 5, get them all aligned, and pass them on to the next part of the pipeline in a day, and then that 6th shot could take you 4 or 5 days or even longer to try to get something useful out of. And so, being pragmatists and understanding that, everything has deadlines and there's a lot of projects going on at the same time, we often do our best to try to have wiggle room and say, all right, if that shot's not going to be able to get tracked, we're just going to throw it out or find a replacement shot. But a lot of times we don't have that luxury. So this is PF Track. I'll give you a quick lay of the land, although they have really great training out there. And like I said, because PF Track is a suite of tools, this, I believe that the price point of this is a little higher. For all of the features we use, PF Track is actually overkill. I think there's a lower product on their tier. PF Track, this version does have a lot of stereo features. So we haven't really done any stereo tracking, but it does have a lot of features that are built in for visual effects companies that are doing tracking and then applying it to stereo rigs so they can do true 3D shot tracks. So we're not going to use any of that. They also do have a couple of things that are built that are sort of simplified interfaces for the whole process. This is essentially one node. PF Track is a node-based system. This is one node where they've combined a bunch of pieces and they've made a version. I'm not going to show you this because it's a more simplified version of what I will show you. So what I'm going to show real quick is, well, first I'm going to do something that, to me, I've just through pure experience have found makes tracking work. 9 times out of 10, it will give me a much quicker solution, and that is to, especially if I have something with a horizon in the shot, is to correct for the barrel distortion. Whereas the barrel distortion in a lot of these shots is so subtle, you would think it shouldn't make a difference. But in my experience, having barrel distortion in a shot will often throw a tracker. It just will. What it does is it causes you to have the wrong field of view, and then when you have the wrong field of view, the track doesn't ever quite match. Which, depending on what you're matching in, the actual content you're matching in, may not matter, because if it's in the center of the shot and the field of view is wrong, it's not wrong enough that you can tell. But if you are doing, say, a turntable shot, and if the perspective is wrong, as you get 3/4 of the way around the building, suddenly nothing is matching anymore. So it can matter a lot, especially if data that you're putting in is closer to the edges of the frame. If it's in the middle, it's more forgiving. If it's at the edges, it can be really wrong. But so here what we have is we have a horizon, which will often be very useful. And there's a node called Undistort, and there's a feature where I can basically drag a line, and I drag it all the way from one edge to the opposite on the horizon, and we can see. Let me get my hotkeys in here. I have a different setup. Oops. But what I do, remember the hotkey for zoom? All right, well, I'm going to use this feature here. I'm just going to pull these points up and put them right on the horizon as close as I can, knowing that this horizon bends like this. And I can add more lines if I have a lot more straight parts of the scene, but usually it's one seems to be enough. But if I do a solve, you'll see that it will now sort of do a little bit of a bow tie shot. Oh, that's what it is. So you can see now it's bent the footage. Theoretically, any long straight lines should now be straight. They're no longer a tiny bit curved. What this does, though, is this makes the canvas of the shot bigger, and just so that I can keep things manageable and not keeping track of all sorts of different render sizes and everything, I'm going to use a transform clip node where, see now it's changed these. This started off as a 1280 by 720 clip. And so I'm just going to change it back. Whoops. 1280, 720. And what I need to reset the palette. And now you see that we can, this side is now fixed, but this side still has it. So I need to actually offset it by the amount. So I don't usually it's relatively round numbers. So what do we have? 20, 50, so I need about 25 offset on the top. And here we were 2018, or 28, so say 16 just for. So now we've got a full rectilinear image that is undistorted. I'm going to just use an auto track. 9 times out of 10, if you can get a good track, all you need to do is use an auto track. And in PF track, this is where I was talking about aerial footage maybe having a different set of numbers than something like green screen footage. I'm going to start off with a higher candidate number and target number than the defaults. I'm going to probably go up to 200 for a candidate number and 80. What PF track does is it tries to find this number of candidates in the shot as it's tracking, and then it throws out all but the 80 best, so it keeps them. The other thing is I like to try to be quick, and you may notice there's a feature called show window, and it will show the size of the item that they're trying to track, and then it shows the window size. This down here, there's a window size and a search range, and so that's what this is representing. And I know, having seen this footage, that it doesn't move very far frame to frame. Even this is where it's moving most quickly. So from one frame to the next. So we can actually, I'm going to turn down the window size down to probably 12, and I can turn down the search range to maybe just 20 for the X and Y. I could even make it, 15 and 25, because I know that I'm only going, in this circumstance, I'm going mostly straight, although these guys over here are moving sideways. So I'll probably just leave it at 20/20 just to split the difference. So that's the show window feature of AutoTrack. And then I'm just going to go ahead and track it. I don't change any of the other features. I've played with them. I haven't really found any reason to tweak them very much. The one key to tracking in general is you want to have parallax. You want to have parts of the scene that are moving differently than other parts of the scene. And that's how the triangulation that the software is happening in the computer is going to be able to really have a lot of data to use to track. Some of the things to really watch out for when doing a track like this. Now again, I did an auto track, and I will show just because it's important. I'm not going to use it when I solve this, but the user track is a really common feature, and it exists in all the tracking software, where this is sort of a little bit more of a manual method, where you pick an item in the scene and you track it because for some reason you know that that's a really good feature. And so here's doing what's called a user track. And you can see over here that if it locks on that object, you end up with data that's useful. And so very often, if you're having trouble or you're having a scene that's not tracking very well, you might have to do a whole bunch of user tracks. And you can see that I like to start and stop user tracks. These are keyframes along here. When you do start and stop, it sets a new starting point. It's no longer trying to match the feature from the very beginning of the frame. So that's more of a, that's just the way I've always done it. And I think software is getting a lot more forgiving now. But back in the day, you had to sort of march through and start and stop feature tracking all the time. But some of the things to think about is when you're doing tracking, there's a lot of things that from one frame to the next will look the same but represent a different place in 3D space. So if you had a tall tower that had a spire on it and then the horizon line, if you picked the place where the spire crossed the horizon line in one shot and then in the next shot you had that same part, if the camera were going up, that crossing represents a different place in space. Whereas Pixel, remember, this software is dumb. It's only got two-dimensional information and it's not smart about what's inside it. So all it's going to do is look for the same matching pixels. So anytime when things cross, or if there's reflections, you know, certainly an area of reflection where there's waves in a water, it can track a bit of pixels that looks the same as it goes, but that doesn't represent real 3D actual locked information. Obviously, you know, the example that's really obvious is like cars on a highway. If there's a whole bunch of cars on a highway, it can track a nice yellow cab as it goes down the road, but that data is not accurate for what's locked down in the space. So reflections can throw you off, crossings can throw you off. Cylindrical objects, I was just tracking an object where the base of the tower is a big cylinder, and I was trying to track a part, but as the camera moved around, it liked to grab a new spot every time, because as the camera rotated, the actual pixels that seemed to match scene to scene were in a different area in 3D space. So cylinders can throw you off. There's a lot of things that the tracking software, as it's chewing on the two-dimensional image, is. Oh, the other big one is skyscrapers. Skyscrapers have lots of great repeatable detail. The problem is that they look exactly the same all the way up the skyscraper, especially if the camera moves. This window frame crossing is the same as the one 2 stories above it, and if it looks in a big enough area, it will actually start jumping around. And so a lot of times you really have to be careful, and that's one of the reasons that when you do look at like an auto track scene like this, you really do have to look, because sometimes some of these tracks will have a little jump in it. We got, you know, this is a pretty safe scene. One of the things that we did that's sort of is an approach choice you make early on is, do you want to mask out a lot of areas if you know that there's going to be bad trackers there, or do you want to just track everything and then delete all of the errant trackers? So if you do have like a highway interchange in the foreground and it grabs a whole bunch of trackers that are on cars, you can go through and mask it. And the way PF Track does it is there's a mask tool that's built into every single one, and you can just build masks around shapes that need to be sort of either, you know, told to exclude. The problem is you have to actually animate them through the scene. It can be, as I said, it's a philosophy that you might use going in. Is, am I going to go through the pain and suffering of masking everything out, or am I going to just track everything and then delete the bad trackers? I would say that I've changed my philosophy on that a couple of times based on the tracking software, what it seems to work better as, and the number of trackers that I decide to use. If I do want to go up to like 300 or 500 trackers and I'm going to have a lot, then I want to mask everything, because I don't want to have to march through every frame and look for trackers that might be wrong. But PF Track does a really good job now of only needing to track a few things. So this is the auto track. As I said, this is a user track, which I'm not going to use because this piece of footage is, you know, and I apologize for having the sort of fallen into the demo track of picking something that works really, really well. But I do want to get through as much, and I do want Matt to have time to show, Matt and Vinny show Nuke. But basically, now that we've got an auto track, we've added a node called a camera solver. And here you can see it's put a 3D scene in. The 3D scene does not move. And it's got a whole bunch of tracking things here, and it's got some features. Typically, I don't bother to change anything. Wait, did I do a... Oh, no, I did an object solver. I was about to say, that did not look right. One thing about PFTrack that's really annoying when I first started using it is that if you hit delete, it doesn't necessarily believe you, so you have to... Whenever you delete something, you have to basically delete it twice. So I wanted to hit camera solver. Okay, so here's the camera solver. Now the one really important part is this focal view. And so you guys heard a lot about this when we're talking about camera matching. The field of view can be really, really useful if you can get it dialed in. A lot of times you'll know that it's right. And there are actually features in here that will allow us to estimate field of view. I'm still having trouble finding some of this stuff sometimes because there's so many. Where is it? There's estimate focal length. There's a really interesting tool here. I'm actually going to put it here where you would basically, going through X, Y, and Z, you pin down perspective lines that represent the perspective in the shot. And as we pointed out, this is sort of a one-point perspective. This PFTrack also, just for everyone's information, is a Y-up environment, so it's closer to Maya than 3D Studio Max in that regard. But it does the calculation pretty well. So if we were to try to get this so that it had a perspective, seemed about right, seeing that perspective line, and now the third point of perspective as long as this is giving us about the right sort of vertical point. So this said 9 millimeters. I'm not a big fan of, sometimes this tool when it gets wide like this really seems to give me some, I think it doesn't like having 1 point perspective. It would be much better if I had 2 distinct perspective points in the shot or approximate to the shot, because what I don't trust is I don't trust this calculation very well. But so that tool exists in here, and it works really well if you have 2 points of perspective. I've found that I don't like to even try. What it will do is in this solver, it will put a number in here. It'll inherit the number from that focal length, and it will say that it's known. And even in older versions of the software, they always had 3 sort of choices: unknown, known, and in some, they used to call it approximate. Now they call it initialized. So even if I know from the camera that it's definitely at 16 millimeter, I still always say initialized or approximate, because the way that it's been cropped, the way that it's been manipulated, perhaps someone from the editing had zoomed in on the footage a little bit. I mean, hopefully not. Hopefully you're tracking sort of pristine footage that hasn't been changed. But I almost always say initialized or unknown. I would never feed a tracker with information and say that I knew that absolutely this is 100% the right thing. So in this case, we're just going to leave it unknown, and we're just going to hit solve and see what it comes up with. So it came up with a cloud pretty quickly here. And in this case, what it often, if PFTrack has trouble with the solution, you'll often see a lot of error lines, and it actually will say, so here's a residual error of, if it's less than half a pixel, then usually you know your track is pretty close. So, but you can see that even though our track, all of these points that it's put in the space are correct, that ground plane isn't anywhere near correct. And we can see from looking at this that, so here's the cloud of data and here's our ground plane. So the next big important step is actually orienting the scene to the data. So the first thing I typically do is find a point that I like. Usually a green one will do, especially if I think it's somewhere near the ground, and I set that as an origin. And then it's a matter of sort of just, this is sort of a best guess, kind of keep messing with something until you get something close, kind of this is a little more akin to traditional camera matching. But what we're doing is and there are actually some features that help out, but you can see that what we're trying to do is we're trying to align this grid to the ground plane. And we're doing this, in this case, just to get it close, but then when we need to actually put the building into the scene, that's when then it gets much more precise and you really got to do it exactly right. And what I've found works really well here too is, especially in this case of this nice one-point perspective, is I can see that my perspective is correct. If I just make the ground plane sort of be an approximate width of Central Park here. Now the project that we're working on is actually all the way down at the end of the park, so before I went too far I would move it down there, but this seems like it's gotten a pretty good track. You can see the helicopter line is a nice smooth line. There are features that will help smooth out the line. If we go back up here into the camera solver, there's things like refine, extend, all of this stuff. But as I mentioned, often when you're tracking the ones that track well, you pretty much, if you ever have to sort of go off the beaten path, it becomes a wormhole of getting things sort of more broken before they get fixed. In this case, this project tracked really well. The one thing I will say though is that, and if I had more time, I would show that the track without that undistort at the beginning was wrong. It kept giving me the wrong perspective. It would stick. Objects would stick, but the actual perspective of the camera that it was able to solve was incorrect. And so if I were to have anything that was going towards the edge of the frame, it would be very hard to get it to match any actual geometry without literally going into max and moving some of the objects to fit the match. But you don't want to have to do that. What you really want is you want to match where the perspective of the lens is truly met close to the perspective. Yeah, basically, if you took the distorted footage to mean that this is a rectilinear image, as Matt just said, it would be as if the entire 3D Studio model should have a little bit of a curve to it so that it could actually match everything, because the tracking software came up with a match where everything was a little bit bowed. So rather than having you build a massing model of a whole city and then having to sort of tweak the edges to bring them down in space to match the barrel distortion, you really just want to get those things to be rectilinear matched. So just to show some of the rest of the features and how this works, the final step, although you will notice that this says 1 meter over here in the corner, which is very, shall we say, incorrect for getting this out into 3D Studio. So the last node here is an export node. Yep, we have a question. So.
Sorry. With respect to the software, I mean, it's another important investment for a company to purchase the right software just for camera tracking. It's something that we would not use in 100% of all the different videos. So what were the main aspects about PF Track that made you decide that that was the right software to use in different occasions, and how does that compare to other camera tracking software like Bushu or all the others? So that's one question, and then the other question I have is, we've had we found that the most difficult scenes are usually at dusk or night shots, because we don't have that kind of high contrast image coming from the daylight. So how do you, what are your tricks, or what type of tricks do you have doing the camera tracking for night shots? And do you have any specific camera and lens that you recommend in order to make life easier?
Great. So I'll take the first question was about the choice of software based on the cost, because it is very expensive. And I think that the first real 3D tracking software we had was called Bushu Bullet, back when they had sort of a version that it wasn't their full cost suite. It was a step down. And we used that for years and years, and it was basically based on cost. So at that point in time, probably 10 years ago, the tracking software that existed on the market, and there were only 3 or 4, I think RealViz, them, 3D Equalizer, and maybe 1 or 2 others in the marketplace, all had mostly the same features. I don't think that there was any real, killer app. There wasn't one that was just, that one was always going to work and the other ones were always going to break. But when we could do it, it was a matter of cost. So we were able to afford what was then called Bushu Bullet. When we got into knowing that it was getting a little bit old and they were no longer supporting it, they no longer even offered that software. We were looking at different software, and PF Track is very popular with some of the people that we work with in the UK, and they really loved it. And so we gave it and there's actually a lot of features of PF Track that I am not even familiar with. Certainly, if it comes to PF Track, I would say the person who knows it the best is a guy named Mike Marin, and he did a chapter in the book that came out 3 or 4 years ago that was about PF Track, or about tracking and the philosophy behind it, but then also how to use PF Track and some of the under the hood features like object tracking to do aerial tracking, which is a really cool sort of reversed engineer way. But talking to people in the industry 5-6 years ago, PF Track was sort of one of the newest. It was newer on the market, but it was also, they had sort of, I think they had some new features that they had, like some of the object tracking software. So they sort of pulled ahead for a little while. So that was when we made the investment for PF Track. Nowadays, the software, there are still very expensive versions of the software. For us, we couldn't stay with Bushu because their sort of flagship version was so expensive. And again, we don't use it on a day-to-day basis. So some of the things that made the choice for us was, in some cases, the support that they're willing to give us. We hear stories about where their companies are very responsive and will give us help. It seems like a really small nuisance, but coming from my point of view, when it comes to managing everything, I like to know what the licensing scenario is and how robust their network licensing software is. I really despise node-locked software if I can avoid it. So they had good network licensing, and they were definitely supporting it very actively. Some of the software companies went through some cycles of basically maintaining the software, keeping it working on all the different operating systems, but not adding a lot of features. Whereas PF Track, they just seem to do a good job. But I would say that by no means are they the only one I would look at. I think that Bushu has always been on the cutting edge. There's, like I mentioned, there's actually software that I've never heard anyone in ArcViz use, but it's one of the oldest pieces of software that people in Hollywood rely on, and there are people who make their living using this one piece of software called 3D Equalizer out of Germany. I I have no idea even how much it costs. I assume that it's pretty expensive. And then Synthize. Synthize is is the low cost alternative, and we've used it and gotten great results from that as well. And so if the scene is easily tracked, and so these guys are also going to show the standard Nuke 3D tracker in a little bit, and so that's built right into Nuke. So there you've got your compositing environment and 3D tracking right together. So it's getting to be free. The guys from the Pixel Farm actually make a 3D tracker that works right inside After Effects as a plugin, and it does a great job. I don't know how easy it is to get the data out to use in Max. That would be my only fear about that one, but I'm sure that there's probably people who've figured it out. Is there any other software that people use? So, and there's always new ones coming out. In my experience, I don't want to say you always get what you pay for, but usually the software that's we usually shoot for about middle of the road. Just like I was talking yesterday about the Tuesday about the choice of workstations. We can't support having the most expensive, absolute newest of everything all the time. But usually if you go 1 or 2 tiers down from the very top, it gets much more affordable and you get most of the same stuff. So PFTrack is a great piece of software. And like I said, there's a lot of this that we're not even using. We could probably get by with a lower version of it. When we bought it, they only had one sort of tier, and now they've got a lot more. They also have some really interesting high-end stuff called PF Clean, I think, and maybe PF, but they do some great things. I mentioned one of the biggest challenges to doing 3D tracking is how to make a clean plate if you have things like cranes in the shot. And so that's the kind of stuff that the really high-end software will do sort of automatically. We have to use all sorts of hacks and things to try to clean that out. Let me quickly show the export here from nowadays. The preferable way to get it out is through an FBX. The nice thing about this is you can change the scene scale in here, and it will actually get you close. We're going to show it a little more thoroughly in a little bit, but right now we're going to I can just quickly show what it looks like to see to import the stuff into Max, just as a very first step. I apologize, this machine is... One thing is that PFTrack is a non-traditional interface, so when you're in PFTrack, you don't even usually get you can't even get at the start bar. And you also notice that when you're navigating, when you navigate footage, it looks very, for those of you who've been around, it looks very Unixy. But we import. Is that going to launch another version, or is it still? All right, there we go. So real quickly, a lot of the software before this version of PFTrack, it always used a Max script, which seems a little bit archaic, but it actually worked really well. What it would do is it would write a giant Max script file that you would open up in Max and run, and it would make all of the geometry and put in keyframes for all the cameras. So the first thing I do whenever I'm bringing this stuff in is I make it have the actual right render output, 1280 by 720. One thing I should say is that we always try to track the most pristine footage. So this footage had been converted to 1280 by 720, but I would almost always want to be tracking either the 4K version or the 1920 footage. So I changed the render output. This is another really important thing. All of the footage that we almost exclusively work at 24 frames a second. And so all of the footage we shoot is 24 frames a second. And generally everything is 24 frames. A lot of times though, Max defaults to be NTSC, which is 30 frames a second. And if you are importing either a Max script or an FBX, it will actually adopt whatever the timeline is set to. And so what used to take 4 seconds is now, 3.5. And then your footage is it just becomes a real pain. So it's best to try to remember to make sure that that matches right off the bat. I'm going to go to the desktop. There should be, oops. Where did I put that? Oh, I think I didn't put it on the desktop. I think it's just in the Documents folder. Oh, there it is right there. So one of the things that I've found is that I need to turn all of these features on under animation and extra options for it to give us the correct thing. So if we switch to a camera view and we unhide all, for some reason it hides the camera. So you'll see here, now we end up with that 3D camera data. And I've run a little over, so I'm going to let these guys show, because they're going to show this process a lot more in depth in putting the background in. But one of the things to note, and these are all little gotchas that will, so the frame rate thing is a gotcha. The other thing is that when it brings in the FBX, it puts it at frame 1. Many of you guys are all familiar. First frame of Max is what? Frame 0, right? And so a lot of times you'll end up with data that starts on frame 1 and the animation starts on frame 1, but when you bring the background in, it puts it at frame 0, and so now you're 1 frame off, and if there's a little hiccup or jump, suddenly the background jumps, and then your footage jumps, and then it's, broken. So you need to make sure that you keep track of what frame the actual frame it started on. And it can get really complicated because a lot of times we'll use footage where we're actually only tracking, a piece of much longer clip, and we need to track, okay, is it frame 300 starts on frame 541 and goes to frame 800. But then when you bring it in here and you've got it in your compositing package, you need to make sure that you know what frame you're on and what matches what. So sometimes it can be a little bit of a management effort to make sure that you've got the right frame in your timeline, your right frame for your background, and then the right frames matching when you export 3D rendered data and you bring in your background data. Now another thing that I will touch on real quick is that there's also a clip export here. And so it's really important that I would export this clip because now Nuke, or PFTrack, has actually distorted that footage. So the footage that we would bring into the background of Max would be the undistorted clip, but it would still have the barrel distortion. So it's important to export the clip from here so that it gets matched up correctly. There is a, PFTrack ships a Nuke node, a Nuke sort of plugin, so that you can save the distortion parameters from PFTrack and load the same distortion parameters in Nuke. So you can actually you can still use the pristine footage in Nuke and just distort it to match the right, so that then the 3D match works. I'm pretty sure that 3D Studio Max is not going to have any undistort features anytime soon, so you still have to go through this process of exporting the backplate so that you can get the proper matched footage if you do have to undistort it. The barrel distortion will really throw you off, but it's important to know that the barrel distortion is much more exaggerated the wider angle the view. So if you are working with a shot that you know is sort of more telephoto, you can probably skip that. A lot of times I'll actually do it without the barrel distortion first and see if I can get close, because then I don't have to have this whole other side chain of distorted footage that I'm keeping track of. But a lot of times it's worth it because it'll track so easily with the undistorted footage versus the barrel distortion. So that's that. One thing, there's a lot of weird, not weird, there's a lot of non-traditional UI in here, and it's been my experience that a lot of the software uses some sort of wacky ways of organizing. PFTrack is cross-platform, so you can get it for Linux, Mac, or Windows. But once you get used to it, it's not too bad. But right now, I'm going to exit out. You'll notice that there's a little guy running for the door. So you have to quit it, and you don't actually just get to exit. You actually need to exit and then agree that you really do want to exit. Yeah.
I mean, it's quick. You can probably repeat it.
Okay.
If the video footage is a little shaky,
Mhm.
what stage of the workflow do you stabilize?
Yeah. So the question is, if the footage is shaky, at what stage during the process would you want to stabilize it? And it's sort of we've gone through all different process and all different manners of doing this. Very often, if there's a high frequency shake, like there was a shake on the mount, and it's shaking sort of in a very predictable way, and you know that you don't want it to be shaking in your final product, then we would take it out as early as possible. But Matt and Vinny are more in the trenches than I am, so they may have dealt with the circumstances more recently. If the shake is because it's handheld or it gives it a certain level of personality, then I have often tried to track it with the shake in there and actually get it to match, because sometimes if the shake is in there and has a sort of energy or has a good look to it, it can help, because if the match is good, then it makes it really, really stick and really work. We have gone through the process of stabilizing footage, matching the stabilized footage, and then taking that same camera shake and adding it after downstream to put some of the shake back in. Although I think that's a lot of work for not a lot of benefit. In some cases, if you do that, you might as well just add sort of a handheld camera shake in compositing to make it look like it's handheld, because then you can actually sort of give that camera shake its own personality and have it be more sort of choreographed. But we have had the circumstance recently where we had a camera mount that was shaking a lot, right?
Yeah. So just one thing to add, as Nils mentioned, the kind of that high frequency shake, if it's predictable, it might be good to remove that at the beginning just to kind of take one variable out. But if it's kind of more jerky bounces or little hiccups here and there, you might leave those in until after you render everything and composite it together, just for the fact that, I mean, obviously different ways to stabilize. You can do position, rotation, even scaling it. If you do scaling it or any other kind of perspective warping, it's actually changing what the computer thinks the lens information is, so it feels like you're zooming in and out of the shot, which, as Nils mentioned earlier, try not to track zooming shots. So
Yeah.
you have to be careful. If you know it's just going to be slight rotation correction for the stabilization, maybe you can do it ahead of time, but if there's going to be any kind of scaling or perspective warping, then you may want to wait until afterwards.
And can you do that in PFTrack, the stabilization? Is that something that the software offers, or you do it before you even bring it into PFTrack?
I haven't done it in PFTrack in this version. I think that there are features now there were not before, at least in my experience. Although there are so many good features, even in After Effects, to stabilize things, that if I was going to approach that, I would probably sort of do that as a pre-process. I would bring it in and try to cook it, because in a lot of cases, if it's in one clip, it's in all the clips, and you sort of need to just go ahead and bake, and you want to have a clean backplate. So when I've had to do anything like that, and we just sort of just go through that as a separate process. I would bet that there's features in PFTrack to handle that, but I haven't needed to use them.
Yeah, there definitely are nodes and tools in Nuke that you can stabilize, either before or after tracking. So we've been using that a little bit, but mostly the kind of pre-processing and After Effects has been our workflow.
Yeah, it's just more a matter of what tools we're most familiar with. So, that is PF track. Does anyone else have any PF track specific stuff, or even just philosophy of approaching it? Questions or? Over there.
If you know that the video is going to be broadcasted at 2997, and let's say that you had the distortion barrel, so that means that you don't have the full HD plate at the end, but you'll have the distortion on the ends. What do you usually do to complete the frame? That's one, and then to do the time remapping. We had a specific project where we were also rendering in 20 frames per second, and I don't remember what software we used to do the time remap, but it didn't work with the broadcast, and they had to use this also to insert some other CG components. So at the end, I think we didn't have enough time to think at all the different variables, so we ended up re-rendering everything at 2997. I don't know if you've had an solution for that. Thank you.
Yeah, so the, we don't often do, I think we got one over here. We don't often do a lot of stuff that's going to be broadcast. If we know it's going to be 2997 right off the bat, then we'll make sure that our footage is all 2997, or we will conform it before we're even getting started to make sure it's 2997 or 30 frames, whichever is easier, and depending on how long the clips are. 2997, if it's only a few seconds long, 30 frames is the same thing, because it's really just dropping the frame every 1,000 frames. So we will try to match to that. And one of the things that we do is establish right up front, where is this being shown and under what circumstances and how many times and things like that. So we should know ahead of time if we're going to have to shoot something that's going to need to be broadcast. We would work entirely in that. Now, but you did mention having different speeds and time remapping, and sometimes we do have shots. Just recently, there was a shot that was probably about 5 minutes of actual helicopter footage, but I knew that it was not going to be a 5-minute helicopter shot because there's only about 18 seconds in the footage. So we have in the past had to decide, okay, are we going to track, 6,000 frames and then scale the whole thing down to be the right length, or are we going to actually speed it all up right ahead of time and track the much sped up footage? And so that's something that, depending on depending on the level it needs to be sped up, and depending on how drastic that speeding up is going to make it difficult to track, it's a decision we make. It's sort of along the same lines of the stabilization. Either you do the time remapping ahead of time and track, and then that becomes your clean plate, and it's always time remapped. Of course, then you're locked to that's the time remapping that you're going to use. If you do track 6,000 frames and have a 6,000 frame long animation in 3D Studio Max, then you need to render 6,000 frames that you're going to throw out 90% of to get that 18 seconds. But you have a lot more flexibility. So it's, again, there's going to be a judgment call as to what's, hopefully you can do enough pre-planning and production sort of scheduling to make sure you know how much that's going to matter. If your animatic edit is locked and you can say, okay, for sure, the hole that this represents is only going to be 18 seconds long. Maybe you work on something that's 25 seconds so that there's still some leeway, but you don't have to, And so that temporal scaling, though, to your point about trying to scale things and render things at the right frame rate, it's either it's got to be right or it's got to be really off so that when you scale it, you've got enough data to make up the in-between frames or to split things between the frames. It's hard to say that there's a specific recipe for the best way. We luckily don't have to deal with broadcast very often, and when we do, we always work at 2997 right off the bat and make sure that it stays that way. There are, post houses where they have, tens of thousands of dollars versus of hardware that will convert things from 24 to 30 and all of that stuff, and you can add, you can do pull down in After Effects to add making the in-between frames up for going from film to video. But nowadays, 99% of our stuff is going to be seen digitally. or in a presentation or in a kiosk or in a trade show or somewhere like that. So we sort of try to control the output and work at 24 frames. 24 frames for us, this is a whole nother discussion, but for us it was an artistic sort of decision early on. We always wanted to use 24 frames a second because we felt that film, back in the early days, film was more what we were trying to emulate than video. So if you shot at 29.97, theoretically you should use fields, and so it should be really, 59. But everyone knows that you'd much rather watch something on film than you want to watch it on video. So it of course had the convenient side effect that 24 frames is easier to render than 30 frames. So there was a sort of a little bit of a value judgment there where we're like, hey, it's less frames to render, so let's render fewer and then sort of have this cap we can put on saying, oh, we're working on films. So we have another question?
Yeah. In our office in Brazil, we had some problems trying to track scenes that have a camera rotation, like a 360 around the terrain. Is there any tip or any process techniques to do that? Or
yeah, so when we've done a lot of turntable shots, and there's one in particular that I remember doing years ago of a project down in Brooklyn, and it was a big rectangular building. And as the tracking software worked, when I looked at the cloud of information that it was providing, it was a trapezoid, so that's sort of a common occurrence, is that it can track the scene and it can give you a solution where everything seems to match, but the data isn't really very useful because what it's doing is it can't understand that this thing is a rectangle or 90-degree corners. It was making them sort of it was sort of making the whole thing skewed. And usually that was the matter of not having the right field of view. It was coming up with a field of view that was either a little bit wider or a little bit narrower than it should. And in there was a feature called initialized. And what we've done is we've actually run tracks, and if it came up with 20 degrees, but I knew it was a little bit wrong, either it was a little too wide or a little too narrow, I would then say, okay, I'm going to feed it with 18 degrees. I was going to say, it's 18, I think. And so I would change it to 18, run the solution, see if that got it more in the neighborhood, and then I would make it 22 and run the solution. So it was sort of a matter of sort of dancing around until things seemed to get closer. And again, I always use that either approximate or initialized value. I didn't say, make it this value and try. Although I've also done that. Just as if it was really not working, I would say, okay, I want it to be 16 degrees, and I know that it's 16 degrees. Now try to make a solution that matches 16 degrees. Because if the data, it's doing its own little, fuzzy math. And if it's able to make a track where all of the points match, then it's happy. But sometimes that's still not right because that solution exists for multiple field of views. So it's usually, in my experience, it's been a matter of playing with that field of view and trying to narrow in on the right field of view. And a lot of times, if you are doing a turntable, I was just testing it with one of those City Point shots, and I could see that it got a solution that worked, but the city grid didn't match my sort of ground plane grid. That my ground plane grid was a little bit more wide angle than the city grid. So then I just deleted the solution, changed its value to be something that was a little bit narrower, reran it until I sort of liked the field of view that it got. Because that's where that sort of that city grid, as you're spinning around, what should be rectangles, if they are just not quite right, that's usually a matter of that field of view number not landing on the right solution.
There's a couple questions online here as well.
Oh, okay.
First one is, what's your opinion on Mocha as a planar tracker?
I think it's great. I haven't really used it at all, and so I would actually let these guys talk about it. Actually, they're going to talk about that tomorrow in the motion graphics part because they're using that a lot. I think that planar tracking and 2D tracking is there are a lot of circumstances where you can get 99% of the way there without having to do all of this stuff. So if you can, then definitely do, because if in the end the client likes it and it has the right thing in it, then there's no reason to jump through it just because doing it in 3D versus doing it in 2D is a better solution. But like I said, I haven't used Mocha myself very much. I have unfortunately not been in production as much when we've been doing that type. And here, our film group does a lot of the 2D tracking as opposed to the 3D group doing the 3D tracking. So it's a little bit different sort of silos of experience. But that's my...
One other question as well. It says PF Match is the lower version, and I see no difference. Do you recommend the lower version if we don't need stereoscopic?
Yes, that is absolutely what I would look at. Like I said, I don't know the feature sets off the top of my head, but as far as I know, there's nothing in the second tier down from PF Track that doesn't exist in that anybody in this circumstance would use. Again, maybe somebody's getting into stereoscopic. In that case, they're going to need PF Track. But I think that PF Match It probably does everything exactly the same. And they've made a concerted effort to make all of the software look the same, and it's using the same under-the-hood technology. It's just a matter of literally the nodes that are available in the higher-end software. There are just more nodes to those. But I think PF Match It probably has everything that you need. As long as it can output to 3D Studio, then it should be able to do everything that we would use in our industry.
Just that we bought it before that.
We bought it before that one existed, so we just kept upgrading PF Track. So, anybody else? We're good. So Matt and Vinny have some examples in Nuke that they're going to show. Do we want to just roll straight into that, Jeff? Is that good? Okay. So I'll let. Is Vinny taking over?
Yeah.
All right. So Vinny, and like I said, I'm the old guy who's done this. All of my experience is from years ago, and it's probably less relevant than these guys. These guys are truly the top gun right now here doing all this stuff. So thanks, guys. Oh, we have one more question here.
Hi. How do you, when I see that solution that you had on screen like a second ago, how do you know that the horizontal is correct? Because once you put your building there, if that's not perfectly aligned with your
The ground.
Yeah.
Yeah, it'll look like it's underground. Yeah, so that's an important thing. We try, if we can, to track some of the data, and sometimes we'll actually do user tracks that are on a piece of known information, like a building next door or the building that's being replaced. And so we'll use that as a origin point for our ground plane, but very often it becomes a matter of you just got to sort of, render out a lot of previews, and sometimes you do have to move the data. One thing I didn't show that these guys are going to show is that when you bring it in from PF Track, it makes that cloud of data. It's all part of a hierarchy. There's a main scene node point that is the parent of all of the data, and you can grab that point and move it, and you can scale it, and it will scale both the data that's been tracked and the camera. Many of you guys have known that using scaled cameras when you're doing rendering can introduce some problems, especially if you use something like image-based motion blur, because a scaled camera has trouble calculating some of those things under the hood. But for the most part, when it comes to tracking data, we almost always have to scale the cloud of information in Max until we get it lined up perfectly. So part of it is similar to Seth's example and Corey's example. Part of it is a little bit of a black magic of just sort of getting it to look right for the entire clip. And part of it is making sure that as long as it's not moving, then you're going to have to integrate it. One of the things that can always be a problem is if your 3D model may not match perfectly with the existing condition. A lot of times there's hills that if it's only a 3-foot rise from one end of the block to the other, our models and our modelers just build it flat. And so a lot of times you have to sometimes the matches aren't perfect because the model is not perfect. So there's a lot of sort of fudging that goes to make things match in the scene. But mostly if you move that data, you need to, one thing that's really important, and we've had people who've gotten messed up by this is that they'll move the camera. So if you move the camera to make it match in one scene, but you don't move the whole cloud of data, the animation will be wrong. So you have to grab that sort of cloud as if it's one big, giant, amorphous pile of stuff and move it all in concert so that then the camera animation still matches that backplate. But it does take a little bit of starting and stopping. If you can get data that matches known parts of the scene, and you can make sure that that Z in Max or Y in PDF track, if there is data that's on the ground plane and you can put your building and you know that your model, if it's on 0, then it should match. But very often when you do approach something from a long way up, in the distance it looked like it was on the ground, but then once you got close you realize that the actual model is pushed 2 or 3 stories underground. Then you need to work on your match, because if you lift it up just vertically, if you drop the cloud of information down so that now the building is on the ground plane, but then you pull all the way back to the very beginning of the footage and you see that your building is now floating 2 stories above, that's because you need to actually rotate the entire cloud of information to get it to line up in the beginning and the end. But that sort of just becomes a little bit of a sort of similar to dancing around the field of view. You sort of get that cloud of information and you sort of have to manipulate it, both scale, rotate, and position until that 3D data. And one thing that I should also say is we almost always try to move that cloud of data and never change 3D models to match. I mean, theoretically, if you were only ever doing one shot in one model, you could just move the model around until it matched. But very often you've got clients who want to send you an updated model, or you've got more information or different shots. So you don't want to manage 15 different models. You want the model to stay right where it's supposed to be, and you don't want to have to rotate the model, because it gets to be a very dangerous dance to go back and forth. But you want to make sure that cloud of data you can manipulate it to get things lined up properly, and never move the model, never move the camera in by itself, and never try to rotate models into position instead of that. So does that make sense? Does these guys agree? If they agree, then I know I'm on the right track. All right, I'm gonna let them take over for now.
Just one last question. You've got this this solution with the point cloud and the camera, but the camera is a standard camera, I guess. And then when you want to render in V-Ray, you just make a V-Ray physical cam and link it to the standard camera.
Yeah, that's typically what I do. Is I'll make a V-Ray camera and I'll toggle between I'll align the V-Ray camera right to the standard camera.
Yeah.
And then I'll change my field of view to match as close as I can. Sometimes the film back is going to be different.
Yeah.
And so you have to sort of make sure it's identical, perfectly. When you shift from one camera to the next, there should be no movement. And then once I've done that, I just parent it to the other. Okay. But we have in the past written scripts where we can actually just convert, right? We still use that. So we use a script to convert a physical camera or replace it with a V-Ray camera and then have it inherit all of the frames. Yeah. We used to have a way to do it where we could actually try to zero out that scaling too. If a camera had been scaled up by 3,400%, we would actually write a script that would convert it not only to a V-Ray camera, but then also zero it out so it's just at a scale of 1. I don't know if we're that careful about that these days, but we definitely always try to render V-Ray cameras, but that physical camera match usually gets you. It usually works very well. There's usually not too many gotchas. If you get as long as the field of view is right and you link it right to the other camera, it usually works pretty well. So. All right, I'm going to hand this off to Matt and Vinny.
All right, so we're just going to take a look at another project that we've worked on and go through kind of a similar process. Hopefully it'll help to reiterate what Nils had said about how there's a ton of different softwares that do this tracking process, but once you get the basics down in any one of them, it's very similar between them. So I've got Nuke up here. I'm just going to open up a project that I have set up here. And this one's slightly different. Here we have some more turn introduced rather than just a shot that's pushing forward. we've got a shot that's got a little bit of rotation to it. So very similar to PF Track, we've got a node tree going on here. So I've just got a couple copies of this. So it's from the original project. Here's kind of a cleaned up version that I've set up over here on the side. So I kind of pull this over away from that a little bit. So here we've got kind of a very similar stack to what Nils had in PF Track. We've got our initial footage, and usually the first thing you want to check out when you're working in Nuke is the project settings. So I'm going to hit S to bring those up. And again, you just want to make sure that you're working in that 24 frames per second or whatever your standard is. And you want to make sure that you're working the correct aspect ratio here as well, because this will default to, I think, a 4K setting. So in this case, we're tracking 1920 HD. So I had to go in and change that. And then we've also made a selection within this footage. So this was part of a much longer heli shot. So I'll cue this up so that it can play through here. So we've just picked some specific frames that focused on the site we were interested in. And we kind of looked for some of those things that Nils were talking about. We've got a nice smooth set of motion here. We don't have any zooms. It's a locked off camera lens. So we kind of had, I think for this one, it was well over 4,000 frames to kind of go through and figure out which would be the best clip for what we were trying to show off here. So in this case, we've just got an empty site here, and that's where we're going to be dropping in our buildings. So you can see the motion going on here. So like I said, we've got some turn to this. We've also got the addition of a bunch of cars driving in this shot. So that was one of the things Nils had mentioned. These can sometimes throw off a track. So we'll take a look at a few different options we have to work around that. But again, in this one, we've got a nice horizon visible here. That's important to help kind of line up that ground plane. So kind of step through here. So within this tree that I already have set up, we have our camera tracker here that looks very similar to PF Track. It's got all the points dropped in, and then it's got a 3D scene that it's built. And we do have some lens distortion that we're taking out here as well. So what I'm going to do to start out with is I'm just going to make a copy of just our footage over here on the side. We can kind of go through step by step. So close out those other ones, get back to a fresh start here. And in Nuke, whenever you want to add in a node, one of the features that's nice is if you hit tab, it'll just bring up this little menu that you can start to type in. So rather than trying to dig through and find the node, we know we're looking for a camera tracker, so I can just type cam and drop in a camera tracker here. And it'll create that node. We'll double click to get to the options there. And so the very first thing we want to do here is we want to set that range again here. Even though we've set it for our project, if we don't set it again here in the camera tracker, it's going to try to track the entire piece of footage. So here under analysis, we're going to switch to analysis range. We're going to set those frames here for the section that we're interested in. As you get into some of the higher settings here in Nuke, these tracks can be fairly slow. We've certainly had ones that take over an hour for just the range that we're doing. So you don't want to go and track, thousands of extra frames when you have that much time involved. Because like Nils was saying, sometimes it's one of those things where you have to go through and do it several times to get a solve that you like. So we'll make sure that's set up there. And we'll jump over to the tracking tab. These are kind of the base settings for the 2D solve here. So we've got the number of features. And usually I bump this up a little bit to start out with, but not super high. So in this case, I'm going to double it and go up to 300. I find that gives me pretty good base most of the time. And if we want to see those, we can just check on these two boxes for preview and refine. You can get an idea of the spread that you've got going on here. One thing initially that I see as being a potential problem here is we've got a lot of points up here in the sky that are going to be tracking clouds. And so when it tries to calculate that solve, it's got these points that are potentially miles away from our site, and that can easily throw this off. So just like in PF Track, we have the ability to add in masks here in Nuke. So I'm going to come off on the side here, and I'm going to add in what's called a Roto Node. And we'll double click on that. And what I'd like to do with this is just change my draw type from Bezier to rectangle, since we've got a fairly straightforward shape up here that we want to get rid of. I'm just going to draw out a quick rectangle over the top part of the footage here. If we play through part of this, you can see that in this case it actually works out because the horizon stays pretty steady. We don't have to animate this. You can easily, just from within this node at any point, move any of these around and it'll auto key that. So we'll come back to our camera tracker node here. You can see our source was automatically set up because we had that selected, but we've got a little arrow on the side here, and if we start to drag out from that, you can see that this is our mask. So I'm going to bring that up and drop that onto this Roto node here. We'll switch back to the camera tracker settings. And in order for this to be active, for it to take this mask into account, we need to come back to camera tracker here. And we've got a mask input. So we need to switch that to mask alpha. You can see it'll redistribute the points down here just around our site, which is what we want. We'll jump back into tracking here. And I'm going to zoom up on this a little bit. So this is a fairly good distribution of points. One thing that I do usually adjust is this feature separation here. If I start to increase this amount a little bit, maybe up to like 600, say, you can see what's happening is we're getting a lot of little clusters of points, and there are a lot of areas that are kind of out in the open that aren't getting quite so many. So in this case, this would probably be fine, but in general, I find that a lot of these solves will work better if you have a little more even distribution of some of these. So what you can do is use this feature separation. This is kind of a radius around each point that it won't allow other track points to fall within that radius. So if we start to increase this, it'll start to spread out these points a little more. So if I bring that up to, like, say 20 here, you can see it'll just redistribute those a little bit to have a little more space between them. So we'll get some points on this building, and it'll offset some of those other ones to different locations now. So we'll get kind of a more even solve across the board. We've also got some options for the track lengths. So the min length here is one that I use a lot. In this example, we've got a lot of cars on the street. In Nil's example, we had water, which is something that comes up a lot. And this minimum length can help to solve some problems that might arise from some of those. Essentially, this is how long an object needs to stay visible and meet the requirements for the track before it gets dropped. So 3 frames is fairly short. You can easily have a car that has a specular highlight for 3 frames, but as you start to increase this value here, I'm going to bump it up to 8 for this example. A lot of times you'll have things like that, little anomalies that come up, but they don't last that long. So we've done some water tracking shots recently where you had the reflections on all the waves that would come up for a few frames. So we actually went up as high as like 20 for this value, and that completely dropped all those, and it was just getting points on our building and on the shore. So that can be really useful. Usually 8 I find to be good enough at this distance to drop out a lot of cars too, because this would be kind of a complicated shot to go in and roto out these streets and those cars for. So usually I'll try to get it here first before I go in and do any manual rotoing. And then if this isn't working, I'll go back and draw in those Bezier points around this shape to mask that out. And I'll just do that within the same node that I've got my rectangle for the sky here. We've got a few additional settings here, and these are for kind of the consistency of the track and trying to remove some of those jitters. But like Nils was talking about, a lot of times I like to leave these ones at the defaults, because as you start to tweak some of these values, it kind of becomes a rabbit hole of things are going to get way worse before they get better. And I find oftentimes the defaults do a pretty good job. So usually I'll just run a track through without kind of changing any of these and make a judgment call from there for what needs to be adjusted to improve this. The only thing that I will set right off the bat is if you've got just a rotating camera, you want to make sure, if there's no change in position happening, you want to make sure you tell Nuke that so that it's doing the correct solve and it's not trying to introduce position where there isn't any. So come back to...
And that would be if the camera was locked on a tripod or something like that.
Exactly, yeah.
It's just a nodal pan, and the cloud, the point cloud that it solves is going to look a lot different than the 3D cloud. It's going to be mapped to the inside of a sphere, which is a little different to match, but just to know what kind of shot you have ahead of time.
So we'll come back to camera tracker. I'll just do a quick track on this. And we'll let this run through for a minute here. Just like with PF track, this is going to give us all our point solving, and exactly the same when we go through and solve our camera, it'll do the same color coding. So we'll get green tracks that are, within the smallest error threshold, and we'll have red ones that it's not going to use. And usually, it is a little bit slower. Usually, I like to watch this process and try to make sure that I'm identifying any potential problems at this stage. It kind of gives you a slow playback so you can see, if there's a point that's traveling with a car or something like that that's way off. This is a good stage to identify some of those issues and even cancel and change some of those settings before you run through the whole thing. Like I said, this is fairly low settings, but as you start to increase the quality for some of these, which we have had to do at some points, it's going to start to take a lot longer. So you want to make sure that you identify potential problems before you run through the whole thing. And just from watching some of these cars on the street, it looks like it's grabbing some of them for a frame or two and then immediately dropping them as they fall outside of that threshold. So I'm just kind of keeping an eye on some of those to make sure that they're not falling within that threshold. They're not going to offset our track too much. Another thing to identify at this stage is, like Nils was talking about, when you have repeating elements on buildings, a lot of times tracks can jump very easily between those. So just kind of keeping an eye on some of these, making sure we're not getting any slipping happening on these points. This is a good speed actually to watch those things for, because when we play this back at real time, those will be a little more difficult to identify. So that's all set. So kind of the next step to talk about here is the actual solving of the camera lens. So this gives us all our 2D points. And if we switch over to the solver tab here, this is where we get the settings for the camera itself. So just like with PF Track, we've got options for unknown constant, approximate constant, and known. The varying would be if you had zooms going on within your shot. You could use those, which, like Nils said, we try to avoid at all costs. I usually like to leave it at unknown constant for the first one. And then if I have problems with the solve, I'll go back and try to manually put in. Usually we know, because we are the ones taking the footage, what the actual lens is. But again, here in Nuke, I always do approximate. I've never actually done known for reasons like Nils said, you know, if it had been cropped in slightly or anything like that, there is a margin for error there. And then down here we've got some options for quality as well. So the default is low, we're going to leave it at low. Usually I'll try one at low and see what kind of solve that gives me. For a simple move like this, a lot of times this can work. But for anything that is much faster, you usually want to bump this up to at least medium, if not high, which we have had to do. And you've also got options here for a reference frame and 3-frame initialization, which I've used a lot. So you can actually tell it kind of a frame in your sequence to look at and try to base the solve around. So a lot of times if I have a solve that looks good throughout a lot of it and it slips in one particular area, I'll pick that frame out and use that as my reference frame. And then we use a 3-frame initialization around that, so it'll kind of pick 3 points around there. And that'll help kind of solve that area. For now, we'll leave it at the default. And we'll jump back into camera tracker here. We'll hit solve camera. And this will run through and create the actual 3D camera. So that's all set. We've got a pretty good distribution of green points here. We've got some red, which are going to be ones that are not used in the solve. And that's normal. Very rarely do I have one that's all green completely. Usually it has some points that it drops. And then as we get further away in the background here, we've got a lot more orange, which are kind of like mid-range. They have some usable data, not quite as much. And that's totally fine. You know, we've got our site is right here. We've got a bunch of points centered around that. So as long as your distribution is fairly close, I find that to usually work fine. And I'll hit the create scene here. You have an option just to create the camera and output that. But the create scene will actually create a 3D element for each one of these points. And that's going to be important for when Matt brings this data into Max. You want to have those points as reference as well. So I'll hit that. It'll create a few new nodes down here for us. So we've got this tracker point cloud is, like I said, it's all these 2D points converted into a 3D helper. We've got our camera, and then we've got an actual node for our scene as well. And just like in PF Track, we can toggle this to a 3D view here, and we can take a look at our scene. And usually I like to just jump over here and make sure that everything looks flat. We can check out from like a left view or a front view. And make sure that everything is not totally skewed or slanted. So check from the front as well. That's looking fine. And so we'll switch back to 2D here. So again, with this one, just like in PF Track, we need to kind of assign a ground plane for this as well. So in Nuke, it's slightly different. What we're going to do is just select some points that are on the plane that we want to use. So I'll just kind of shift drag around here, and I try to err on the side of getting more points than less. It does a pretty good job of solving for them, so I like to grab a pretty good distribution of these. And when I'm happy with that, I'll right-click, come down to ground plane, and just hit set to selected. It'll give us a visual indicator that those are the ones being used. And then again here, just like in PF Track, I like to set an origin. So I'm going to drop in a cube somewhere over here where the site is. So I'd like the origin to be over there. So I'll come down again to ground plane. And this time with just one point selected, I'll hit set origin on that. And at this stage, what we can do is we can switch this back to our 3D view. And we can actually look through our camera. So I'll switch this from default to our camera. And I'll set this so we're looking through our scene and we want to look over that original footage. So it looks like we're a little skewed here. So we can come in and correct that on our camera tracker. We've got those rotation values as well. So just like Nils did, we can start to dial in some values here. And Nuke is also a Y-up environment. So try to get that close, and then a lot of times I like to just rotate the scene so that the perspective lines are matching with something from the site. So I'll take my Y value here and try to spin this. So we've got something that's matching there with our road. And jump back to our 2D view here. And what you can do is, on any one of these points, you can actually create a piece of geometry. So I'm going to jump down to Create here. And I'll choose Cube. And it's going to drop in a cube node here in my hierarchy. And I'm just going to plug that directly into the scene. And when we switch back to our 3D view here, we've got that cube placed. And what we can do is over here in the settings for it, we can begin to scale and move this into place. So we scale this down some, and in Nuke, if you highlight any number and then roll your mouse wheel over it, it's going to start to dial that value. So I find the actual gizmo in the viewport to be a little difficult to work with. So usually I kind of work by just dialing these values here in the spinners rather than over there. So we'll start to move this guy into place. Yeah. I was going to check what the setting was on the original. So I'll kind of get that into place, and then you can play this back from this view and see how our solve is looking. In this particular case, it looks like the solve was a little extreme in terms of the focal length. It's probably a little bit off here. You can see our perspective lines probably not matching in distance, even though they are here. And you can see that this guy looks like it's slipping a little bit. But in general, this is staying. It looks like the solve did a good job. This is staying where it should. It just looks like the perspective is off. So I'd be resolving for the camera in this case, not necessarily doing the whole track over again. And you can see that the perspective on this guy just looks off relative to the other things in the scene. So in order to check that, if you jump up to the camera tracker node here, and you switch over to the scene where we are, the output, you can see what it's giving you for a focal length from that solve. In this case, it's 11. If I jump back to the one that I had set up earlier, this one is a 35. So this is probably a little closer to what this was shot with. So if I pipe that into our scene here, and we take a look through that, You can see that the perspective on this one is probably matching a little bit better. So if we check out on this one, I think I did a few less tracker points in this one actually than I had in ours. So that can introduce problems as well. So we've got that turned down. And then for the solver, it was actually the exact same settings. You know, it was unknown constant, it was low. So that's kind of that thing Nils was talking about. It can be a little bit almost like black magic at some points. Just changing one value slightly can totally throw off that solve. So usually kind of sticking as close to the defaults as possible, and then only moving away from them as you feel like you need to. So we've got a solve that's fairly good. One thing that you do need to do here is you need to scale this scene. And like Nils said, usually when you get into Max, you have to scale the data anyway. But one thing we found from Nuke is the default for your scene scale is 1. And usually we set it to something over 20,000. And the reason why is because the scale of 1 in coming into 3D Studio Max is so small that it actually starts to clip values. So it'll have keyframes that the difference is so slight between, it'll actually just drop the keyframe within FBX, and there's no settings to control that. So a little after lunch, Matt is going to show bringing this data in. But one thing you want to make sure is that you're setting a scene value here of at least 20,000. And you also want to check your data the very first thing when you get into Max and make sure that you should have solid keyframes for position, rotation, scale for every axis on this camera. If you have sections where there are no keyframes, that means that data is being dropped on the import, and you need to come back in here and scale up this value. So from here, we can zoom back down to our scene node. We'll hit tab, and we'll add in a right geometry node. And we'll pipe that right into our scene. We want to take the entire scene, including our camera, including the points, and including that cube that we created, so that we have those visual references once we get into 3D Studio Max. So we'll bring up the settings for that. And again, this is going to be an FBX file. So I'll export out this file as an FBX. And we'll hit execute here. It'll automatically choose our frame range for us. So we'll hit OK. And that'll run through and create that file for us.
Got a question over?
Do you have an example of camera tracking night scene?
We could probably put one together for after lunch.
Oh, okay. It's just that like, the problems we found is that usually if it's later on at night, the key points are really lights from the buildings, and sometimes they go on and off, so you lost the tracking point. You have also probably a silhouette of the buildings, but that all depends on the quality of the film or the camera, and that leads me to the next question, that is, for night shots, what type of camera settings do you use for the ISO in order to have a crisper image?
So to your first point about the kind of quality of the footage, there may be a couple things you need to do ahead of time. You may need to actually color correct, or whether you're adding in some contrast or some more information, trying to because behind the hood, the tracking software is trying to pick up on key points, high contrast points. So you may need to pre-process it and actually track a different version of the footage than what was shot, just so that it picks up on better points. You may also need to do some more selective masking or deleting of points if it is picking up on some of those lights that are going on and off, because that will obviously throw it off. Another thing that you can do that Nils touched on briefly is the user. Is the user tracks, where you manually select a point and make sure it tracks through that. So in tougher to track shots like the night shots, it may require some more hands-on attention than just the auto tracker. The second part of your question about the ISO, I mean, that's always a kind of a tricky situation, and it's kind of dependent on what the equipment you have. The guys tomorrow are going to go a little more in depth on the actual helicopter shoot production and like kind of the planning that goes into that and some of the camera and lens information. But typically we try not to shoot at like very far into night. I mean, at dusk or later in the afternoon when you still can get some information. I mean, if a client requests you need it to be night, then you have to kind of think of ways around that. But ideally we're not shooting when there's that little information. One plugin that we use here is called Neat Video. I don't know, can you maybe go to the website real quick? Just forget the name of it, but if you just search Neat Video. Yeah, it's not the prettiest site here, but it's super cheap. I think it's $100. It works with $99. It works with After Effects, Premiere, what else? Final Cut, a few other applications, but it's awesome. It does a great job at reducing noise, whether it's from ISO settings or if you have some like high frequency noise, any kind of like RF interference. It does a great job of extracting that. And we've even started to use it more recently on CG renders. We've been doing more kind of compositing where we build up the shots from the ground up in post and using the different element passes, the V-Ray elements. So kind of the most common element that has the noise in it is the reflection element. Some of the other like GI elements might, but the reflection is the biggest thing with glossy reflection. So we've been using this plugin on just the reflection element to clean up the noise, and then when you add everything back together, you'll get a very smooth shot. It's kind of a balance with, obviously you can remove some of that out of max by increasing the render settings or the subdivisions of the material, but then you're going to take a huge hit on render time. We found this plugin does a pretty good job of removing it, and it's almost real time. Maybe we can do a demo later with it in After Effects, but you add it to your shot and you kind of play the footage back. There's almost no, once it builds that noise profile to remove it, there's almost no kind of computation time. So it's not a huge hit in the post side of things. So that could be a solution if you're finding your footage to be noisy or have some interference like that.
Couple questions online here. First one, for full HD animation, you use only 24 frames. Are these acceptable if you're not making any use in TV or screens? I'm not sure if that's clear or not.
Could you repeat that?
It says here for full HD, you use only 24 frames. Are these acceptable if you're not making any use in TV or on screens?
Yeah, typically the films we finish are at 1280, 720, but we've been doing a lot more at full HD now, 1920, 1080, and we haven't had the need to change any frame rates. You know, playing back at the higher resolution has been fine for our needs. As Nils said, you know, pretty much exclusively non-broadcast, but I wouldn't anticipate any issues with the higher resolution at the lower frame rate. I think that would be fine.
Okay. There's one other question here as well about what is the best shape for marking the green screen?
The best shape? You want definitely high contrast and things with you know, harsh angles. You don't want any circular or cylindrical shapes. Yeah, corners. I mean, Nils mentioned it about the rounded building, but that's the same thing if you have a white piece of paper with a black circle on it. It's not going to track well. So
Triangles, cubes, crosshairs. We have kind of an array of those on the markers that we use.
there's a lot of resources online. If you just search for tracking points or tracking markers, you'll see a bunch of things that you can save and print out. And yeah, you really just want the high contrast and the corners. And I mean, you can do a quick test in your studio, print them out, and tape them up to the wall, and do a quick capture from a camera, and just to see kind of what it's doing. But it doesn't take much. But on the other side of that, having other pieces of equipment lying around on the ground or hanging from the ceiling, kind of anything else for the software to pick up is always good. You don't want it to cross your actors because then you had to roto it out. But you know, we like to put light stands and tripods and things like that at different depths in the green screen area when we're filming, as long as it doesn't cross the people, just as a secondary source for the tracking software to pick up points on, in addition to the actual tracking markers that we put on the wall.
I don't know if you're going to show a scene, like a green screen scene, where you can track the markers. Like we've been also interested to track cameras that are completely manually held and with very little quality, like let's say a video that comes from an iPhone, just for, well, it's one of the ideas. So I don't know if you have had any experience on that, what are the difficulties, and if you have a sample that you can show us.
Sure. I mean, the two examples we've gone through so far this morning have been pretty standard, kind of easy helicopter shots, that track nicely. But to your point, not all the shots are going to be like that. So, yeah, they're harder to track and more things to kind of keep in mind. I think the biggest thing we found with the handheld shots is the motion blur. If you're moving the camera a lot, you can get some streaks and blurs that aren't going to track well. So making sure that the shutter speed on your camera, if you can control it, is set to a high enough shutter speed that if the camera does move, you won't get that motion blur. Obviously, the playback on that is going to be a little more jittery, but you can then introduce some motion blur in post to kind of soften it back out. Obviously, a little bit of a hack, but it certainly helps with the tracking side of things. You'll probably also need to do more manual user tracks on those. Just throwing it through the auto track probably won't work as well as the aerial shots. So, yes, you can track pretty much any shot with enough time, but we try to control as much as we can, and obviously it's not the case every time, but as much planning as you can put in ahead of time, knowing that you're going to track it. So even if you're doing handheld or even on your iPhone, just making sure that you're keeping it in mind that I'm going to try to track this, so I shouldn't be moving the camera around crazy, or even if you only want a small chunk of it, tracking more on the beginning and end, having those handles and getting that parallax. So even if you're just having your phone and you want to track something on the desk and you just want this motion, you may want to actually move around a bit more before and after during the same take, and then track the whole thing. It may be able to build a better 3D solution from that. So just things like that to keep in mind.
There's one more question online again here. Do you use manual tracking or auto on green screens?
We'll certainly try the auto tracking to start with, and hopefully we've prepped the space and planned it out enough that the auto tracker will work, using enough tracking points and things to pick up on. But certainly if it doesn't have enough information, which may be the case with the green screen, a lot more so than with helicopter shots and things like that, you may need to do some manual tracks. We've certainly run into some cases where we've gotten green screen shots, maybe secondhand, or were shot at an outside studio, maybe not with the proper planning, and as much as you try on some of them, you ultimately may not be able to use them if there's not enough tracking points or information to pick up on. I mean, it comes down to, are you just going to hand keyframe the solve, and usually that's not going to work for a finished product. So, you can say you can track anything, but there are certain cases where it's ultimately not going to work out and be worth it. So, there is certainly a cutoff. So I just to reiterate, as much planning as you can do ahead of time is going to save you in the end. Nils mentioned being able to track 5 shots in one day with relative ease, and then having one that takes 4 or 5 days just for one shot and maybe not even being perfect. That's not an ideal situation. So, don't feel like you need to come up with a solution for it. If you need to cut it and move on, then do that, because it's going to ultimately be better for the whole process.
So I think we're going to take a break for lunch, and then when we come back, import this data into 3D Studio Max.
Okay, good afternoon, everybody. We're going to get started now. The next section here is going to be about 90 minutes long, so it'll be the last half of our section before lunch, and then we'll move into the last part of the day, and that'll be another 90 minutes. So we'll probably end up, probably somewhere around 5 o'clock that will end, depending on how questions go, and if we run a little bit long, but I would target that. So with that, I'll pass it over to you guys to carry on.
So just to close the loop real quick on a question that I think you had before lunch about the night shots, tracking of night shots. So this was a project that we just finished recently in New York City, and we had a day shoot, but then we also had a night shoot. I think you might have seen the finished movie yesterday. You might recognize one of the clips here. It's the South Street Seaport movie. So this kind of shows 2 parts to what you were talking about earlier. This is the kind of the raw capture of the footage. And you'll notice there's all this like noise and color banding, and we're still not sure exactly what went wrong, but it was some issue, saving the footage to the deck, I think, because we couldn't preview this when we were in the helicopter. It was only afterwards when we were reviewing the footage. So we kind of freaked out at first and weren't sure, because it was over all the shots, and some worse than others, but it's kind of unfortunate. But that plugin I mentioned earlier, the Neat Video, it cleaned it up with relatively little effort, and it was able to isolate. It can split it out into different channels, so it can look at the luminance channels versus some of the other color channels, and the interference is actually only in the color channels, so it actually blurred like the red and the green channels to eliminate that. So we that plugin more than paid for itself there, but we've used it for a lot of other things too. I don't know if this, this isn't still quite night. It's kind of right at magic hour, but I don't know if the shots that you've been working with have been later on in the evening where it's a lot less information than this.
Yes, well, for that specific project, yes, we have some shots like this. For that specific project, we took some shots at dusk just to be safe. Our client wanted to have complete dark night shots, so those were the ones that are trickier to track. Where because for example, right here you at least have the contrast of the silhouette of the skyline with the nice sun rising. But once everything's dark, then you don't have as many points to track, right?
And just one other point about that, it can't work in every case, but if you know you want it to be later in the night, but you know that the tracking and the footage is going to look better a little earlier, if you're able to shoot a little earlier and then, through color correction and other post techniques to make it seem like it's later at night. We've taken day shots and turned them into night with putting fake lights in buildings. Obviously, that's a little more of a giveaway, but taking a dust shot and making it night, as long as there's some buildings that already have lights on, you may be able to get away with it more and still make it convincing, but have your tracking and compositing process be a little smoother.
Right. Thank you.
So going back to the shots we were working on this morning. So we're done with the tracking portion. Now you have the data. Nils touched on it a little bit, importing the data, but I'm going to show you now how to actually work with the data in Max, aligning it to the model, things to do, things to keep an eye out for. And then after that, go into how to set up and match the proper lighting for what you shot. And then different rendering techniques for getting the right passes you need to composite it back in with the back plate, and then exporting the 3D data one step further from Max into After Effects, and then using the data in yet another program for things like rotoing or patching things that may need to be fixed. So first off here, this is the 3D site that goes on top of the shot that Vinny was working with. That's not good.
F5.
F5? Hey, thanks. So this sequence here, this big empty pad, that's where the 3D site is going, just to give you a sense. So this is our model. So first off, let me just hide everything to make it easier to work with. And I'm going to create a new layer, because when you import the FBX, it's going to dump it on whatever layer is active, so just to get it off layer 0. So just to go through it real quick again, just regular import. Open up the FBX that was exported. In this case, it was the one from Nuke. I usually leave these default. Nils checked them off anyway, but everything should work as long as you have. Actually, I do change it to the media and entertainment. Seems to work just fine. It has less options, but haven't needed the other extra options. So import that. It's going to run through creating the camera and all the points. Let's take a second. And I'm going to have to do it again because I forgot to go through the checklist. So as Nils mentioned, first off, you want to make sure the frame rate is right, because that information isn't saved in the FBX. So we know we're doing a 24 frames a second shot. So we want to change it to film first, because if you don't, it will try to conform the keyframes and make them fit whatever your timeline is. And trying to stretch or or adjust those keys once they're set is not ideal, so we want to set the frame rate first. And I'll also set the render size to 1280 720. And then also just turn on safe frames. Once we start working with the viewport background, it behaves a little better if you have the safe frames on, or it may not align properly with the viewport. So now, go back and import that again. So if you remember to the presentation right before lunch, Vinny had to set the range in Nuke to the range we want to track. And that keyframe, or those frame numbers get translated through. So it's going to put the keyframes of the camera at those exact frames. So once this finishes, we're going to have to adjust the timeline to kind of capture that range. And I know that it was in the high 2000s, so if I set our end time to 3000 here, you'll see the keys at the end. I can trim it just to make it a little easier. I think it's 2760. So there we are. If we look at the hierarchy real quick, there is none, at least with the Nuke import. I think the way that PF track makes the FBX, it will link everything up properly with a master null point, but this just puts it all on the base level. So we're going to have to link everything up so we can manipulate it. But before we do that, I'm just going to clean up some of the points just to keep the system a little more contained. We don't need nearly half of these points, so I'm just going to delete ones that are a little further away. This is kind of personal preference, but you can really get rid of a lot of them, and it just kind of keeps the whole system a little more manageable. If you'll notice, this one was from the actual project that we exported, and we went through in a little more detail, creating some rough 3D shapes and bringing those into Nuke to help with the alignment of it. I'm going to actually just get rid of those now because we could be done with this in a couple minutes by having this geometry in here, but if you didn't have that, I'll show how to align it with just the cloud. So let me just delete these guys. Assuming that all you're going to have is the point cloud and the camera. So now that we cleaned it up a little, I'm going to create yet another empty layer, which I'll explain in a second. So you can manually easily create a null or a point and then link everything up. We have a script here that Vinny wrote that is pretty easy to just do that for you, but it also creates a V-Ray camera, aligns it to the standard camera, and sets the correct focal length. I think someone had a question this morning about matching the right V-Ray camera, so after I run the script, I'll show you how that works. But just to run through real quick, so we are going to supply some of these scripts afterwards if you guys want to take them with you and try them out. So this is one of them. But I can just run through it real quick. Basically creates a new point. It sets the position to the center of the cloud, the point cloud here. You have to have the whole cloud and the camera selected first. That's the way it works. So it runs through the selection. It checks to see if the class of the selected object is a dummy. If it is, it creates a new point at the old point, aligns the positions, and links that new point to the parent point. And it's going to run through that for all the points here. And then if the class is a camera, which there should only be one camera, it's going to set the parent of that camera to the original, the master point. It's going to create a new V-Ray camera, turn targeting off, copy and paste the transform controller from the standard camera to the V-Ray camera, or vice versa. Link the parent, set the parent of the V-Ray camera to the standard camera, and then these two lines set the proper focal length and the film back, the two values in the V-Ray camera that you need to match, so it grabs the aperture width in the render output and sets it as the film back, and then it grabs the lens length or whatever it's called in the standard camera. What is it? Yeah, lens, and sets that to the focal length in the V-Ray camera. So, like I said, we'll give that to you guys after this. So I'm just going to select everything and run this. Now, if we look at the hierarchy again, we still have, let's see, display. We still have all these old points that are, so another thing that this new script does is all of the points it creates are instant, so if you change the size of the point, it will change the size of all the others. By default, when you import these, all the points are uninstant, so if you want to see them differently, you're not going to be able to that easily, so we're going to auto save here. We're canceling it. So I'm just going to delete all the old ones because we don't need those anymore. And now our new hierarchy has the master point, the camera, the standard camera, and the V-Ray camera linked to that, and then all of the other points in the point cloud. And to show you what I meant there, if I select one of these points and change the size, I do 5 feet. They'll all scale up, which you don't get the other way. So when you're looking through the camera, sometimes they come in at a scale that's not, you can't even see them from the viewport. So being able to scale them all up together helps. So from here, I'm going to load in the backplate footage just so we can see it aligned to what we tracked. So go up into the configure viewport background and pick that footage.
One thing to note with that is you do have to export your footage as JPEGs for this to work. Max isn't going to take a QuickTime or a lot of other file formats for the viewport background. So
it used to take QuickTimes, or if you're still running a 32-bit 3ds Max, you can bring in QuickTimes, but I'm guessing most people are on a 64-bit version of the software, and QuickTime isn't supported for 64-bit, so that's why you can't bring in the QuickTimes. But any JPEG or other sequence should work fine. So when you load up the frames, just highlight any one of them and then make sure to hit sequence. Otherwise, we'll just bring in that one frame. It's going to tell you start and end frame, which are going to be lower numbers than the actual frames, but it's just an offset back to 0, so that's fine to hit OK. And then here is where you change the start frame to be at 2761. You have to manually put that in, so then it will offset the whole sequence to match your timeline. And I don't know, there's kind of both ways on that philosophy, whether you work at the actual frame count that the original clip was and what you tracked it, or if you offset everything back to 0. It's kind of personal preference, but we like to keep them at the original range. That's why we're up in the 2700s, and we'll maintain that frame range all the way through to the end to compositing, because when you're rendering out the CG frames, it just makes lining things up easier, and especially if multiple people are touching it, there's no question on how many frames you offset it back and forth. It's just going to drop on top a frame for frame number. So we just want to check here to match the viewport. So now we scrub through, we can see the points line up with the footage. Now, if we were to scrub here, you notice the background doesn't update, but the points do. You can change that in the Customize Preferences under the Viewport tab. There's a checkbox for Update Background while playing. If you check that on, now if you scrub or hit the play button, it will constantly pull the next frame in the sequence. So that's helpful when doing shots like this. So next thing we're going to want to do is kind of create a pivot point that we're going to be rotating and scaling about. With the FBX import from Nuke, it doesn't create that hierarchy for you, so we had to create that master point to link everything to. And by doing so, if we select it, it's way out here. And rotating and scaling from that point when our site is in the center isn't going to be that good. So you can leave everything the way it is in terms of where the points are, and you can just realign the pivot to something that's going to be a little nicer to work with. So if you go into Effect Pivot Only, you can then align it to a point that you may have information for or is a little closer to the site. So this building right here, we know we have a 3D massing for it, which is part of the model that's hidden. But by having that, we can use that to align the whole site. So I'm going to pick a point that's kind of on the corner or near the corner of that building. So I might actually take one of the top corners because it looks like it's sticking better than some on the ground. And it's hard to know if the ones on the ground are actually like in the trees. So I'm going to pick one of these up here. And I'll show you how that's useful in a second. So it's just changing the pivot point, and it's not actually moving anything. So if I go out here and unhide our buildings, let me hide those again. This is the massing of that building. So I'm actually just going to keep that one on for now and then turn the rest of the site on later, just because it's a little easier to work with. So if I have that on as reference, so I want to select the master point. As Nils and Vinny said earlier, when you bring in the camera information, you don't want to move the camera at all. You're moving the whole system together. So since everything is linked to this point, it all moves together here. So just anytime you do a translation or rotation or scale, just make sure that you have that master point selected. And then from here, I'm just going to align it to the top corner of that building that I set the pivot to. I just kind of eyeball it in a top view and then go into some side view and match it there as well. So I go back into the camera. I guess it was the other corner. No, it's right. So the position of the corner of this building matches the position of the corner of that building in the footage, but nothing else is right. So from here, you do have to do some scaling and rotating just to finesse it a little bit. So the first thing I'll do is scale up the whole system. So this matches a little closer. You can scrub through and check, see that it's sticking. It's a little off here in places, but you can fine-tune that a little bit just by moving the system slightly, rotating it. One other thing to do before you get too far down the line is to turn the horizon line on in your camera. Not all shots you're going to see the horizon line, but when you do, it's a big help to lock down, at least one variable. Any information that you can know is right will help everything else. So the horizon looks pretty good. It's a little off, so we can just tweak the rotation slightly of the system. It doesn't take much. And again, it doesn't have to be perfect. You just want kind of from beginning to end things to line up pretty well. So I won't tweak that anymore right now until I get the rest of the site in there. So we can kind of match this building in. It's lining up pretty well, but you can see it poking out in some places. So it may help to get the rest of our site on. I'm going to unhide all the other buildings. So without knowing the exact extent of the new site, you kind of make some guesses on, the kind of the perspective lines here are kind of matching the edge of the site. Things to look out for is if, the system was kind of rotated funny, like back here or in the road, you might need to tweak that a little bit. But for the most part, this is looking pretty good. So you might just fine-tune it a little bit, just kind of move it into place. I'm using this pink building on the right as my reference point since none of the other buildings exist. It's a little bit of a back and forth. But you can do things like having the horizon line on to check, having other context buildings that are accurate, the right scale and position. In this one, there's a lot of low buildings and not a lot of other features that we have built that we could match to, but even the one building helps a bit. You can go into some other views just to see that the points are kind of matching the right orientation. You'll have a few that are stray, which could have been bad tracks, or maybe they were following cars that didn't get masked out. But with so many points, even if you have some bad ones, it will work out fine. It's going to try to solve them as if they're static points. That's why it puts them underground, even though it might have tracked a moving car. To resolve that point with the rest of the solve, it will put them underground. But with enough points on the main ground plane, you should be fine. So most times you're not going to be able to just hit play in the viewport and preview things. So I'm sure most people have used the render from viewport, but I think they switch it in 2014.
They did.
Yeah, I think
It's in a different place.
It's in Tools, Preview, Grab Viewport now, and you can do create preview animation, and you can set various things: frame range, frame rate, output size, turning on different geometry and shapes and things like that. So with this, we could just do the background and the geometry, and just do it as even a wireframe should be fine. if you hit an AVI, it will create it and bring it up right in memory. But if you do custom file, is that 3000? Thanks. Yeah, AVI will bring it up in memory. You could save it after the fact, but custom file will allow you to save it off the bat. You can still switch it to, unfortunately, AVI is, I think, the only, you can do QuickTime here. So I don't know if it will work in 64-bit. I'm not going to render this out now because it might take a little just pulling all the frames through, but you're able to save the file out here. And I have a version that I already rendered out earlier. So this is what it spit out. Obviously, you get some shimmering with the wireframe, but you can see that the site is, one, it sticks. It doesn't slide throughout the shot, and it's not. That's one thing you want to look out for, and the other thing is if it's jittering at all, whether it's like high frequency, every frame jitters, or if there's big bumps in it, you can notice that here too. But also noticing the horizon line sticking pretty well. So from here, the next step that we would normally do is to set up some lighting. Sometimes you know more information than others. In this case, we know where the site is in reality, so that can help us at least know what direction north is and what part of the world it's on. If you were to use a daylight system to set up a similar lighting, that would help you. So I have in Google Maps here the site. It's, I don't know, a few miles west of where we are. We're down here. It's just down the Mass Pike, down 90, kind of on the edge of Boston. So it's this pad here, this tan building, or rather this building right here is the pink building that we had the massing for. So one thing you'll notice if you're looking at the top down here versus the top down in Max is the site here is, was built at 90 degrees, which most times your buildings in site are, just for ease of modeling and working with it. But in reality, the site is a little rotated. So I'm just going to take a quick screen grab of this and bring it into Max just to find out what that rotation is. I have a file here I already saved. But I'm going to bring that in.
I've got a quick question for you. On your context modeling, is it really critical to accurately model that, to get the height of the building just right, to get the floor plate just right, and this matching? I mean, it looks to me that it is.
I mean, you could spend all day getting it exactly right, but I don't know, you bring it up to 80% or 90%. I mean, even just the general shape. So if you're able to get a Google Maps view, even of the top down, you can trace the right shape, so you get the right footprint. And then I know you can do it in Google Earth. I don't know if doesn't look like the height information is here. Is there Google Earth on this? So one thing you can do, it's not exact, but in Google Earth you can go into a street view and just roll the mouse over a building, and it will estimate the elevation of where that is. So, if we we're starting fresh here, and we wanted to model that context building. This guy here. You notice in the bottom right, if you can see, it says elevation and then eye altitude. So the eye altitude is where the camera is, and as we pan around, it's not changing because it's as if we were standing there moving around. So that's at 34 feet.
And that's above sea level, correct?
Right, right. So if we move down here a little bit and hover over like the corner of, or the edge of this building, it's also roughly at the same value. So the elevation is 35 feet and the eye altitude is 36 feet. As we move up, you'll notice it's tricky because it doesn't know the depth, but you can see that it's trying to lock onto a point, and I think it only works if it has a 3D model under the scenes, but you know, in a lot of cities you at least have that information, so you can get a rough sense if you put your mouse at the top, at the bottom, and take the difference of it. You can get a rough sense of the height that you would need to extrude that top-down plan from. So I think those two steps are probably the most important. From there, you can determine if you need any more or less or more detail, but usually that will get you most of the way there. But it certainly helps if you're doing a track shot to have that information to align it to. If you're, in our cases, we're not going to render those context buildings in this shot, but other times if you're doing even just a still render and you don't necessarily want to use the photo and you want to use textured 3D context buildings, you'd need more detail than that, but for alignment purposes, that should be fine. So let's see. So I saved out that screen grab from Google Earth or Google Maps, and I'm going to just bring that in on a plane here. Uh-oh. Better not go into Slate today.
I think they did uninstall.
Oh, no more crashing. All right, so let me just find that guy. So I'm just going to note real quick the size here. So 1912, 906. We're going to set our plane to the same proportion. So 1912, 906. From there we can scale it up, but just so it's the right aspect ratio. I'm going to just apply that. And there it is. So we're just using this to get the right angle that we'll need to set our sun up at. I can turn some things off here. I'm just going to actually unhide that one building and then an additional bank of buildings that we had modeled as context here. So it's just getting it somewhat close. Might even help to reset the pivot to a known point again, which we can put on the corner of that building. Then when we scale and rotate it, we'll at least keep the position fixed. Especially for this purpose, it doesn't need to be exact, but that's roughly what we're looking at here. Maybe a little up there. So from here, we can get a rotation value that our sun will need to be rotated by. I mean, it's not that big, so we probably could have just used a daylight system and not worried about it because it's only 11 degrees rotated, so that's probably not going to make a big difference, but you may have one that's rotated closer to 90 degrees to get the right angles to be in a better space. So in that case, you would need to rotate it further. So we'll just keep that number handy for now. And I'm going to go in and make a daylight system. You haven't used that before. It's just in the Create tab under Systems, Daylight. And when you click and drag it out, it's going to make a compass and a sun and sky. It's going to scale this compass down a little. So with your sun and sky here, I create standard for the direct light, and then it's just a default skylight. I'm going to turn the skylight off because unfortunately it doesn't have a V-Ray light or V-Ray dome light that you can link in directly, but we can pipe that in elsewhere. And then the sunlight I'll change to V-Ray light. It's going to ask if I want to add it to the environment map, which I can add it for now, which will help when dialing in the exposure on the camera in a minute. So what we're going to do here, since this is direct light, it can be positioned anywhere. But so we want to rotate this compass and not our model, the 11 degrees. And you can do that by just selecting any part of the system and going into the motion tab here. And you have some options. Time of day, date, location. So before we rotate it, we'll get our location here. We're in Boston. And I know this was taken in the summer, so I don't know, July sometime. If we had the timestamp on the file, which I don't know if we have for this, you can check and plug it in exactly, but getting a rough estimate will be fine. And I'm going to leave the time of day alone right now because we know that it was during the day, but not sure what time yet. But we'll experiment with that in a minute. So now we just need to rotate that compass into place. Unfortunately, you can't go negative. You only can go from 0 to 359.9. So we have to just do a little subtraction and take the 11 degrees out of 360. So it's going to be 349. And you can see how, it's matching the angle of the rotated plane. So now we have our daylight system rotated correctly. So if we jump back into our camera, it's going to hide that plane. So if we just look at the footage, without knowing the exact time of day, we can see that the sun is coming from the right side with the way the shadows are. So to the right of our massing building. And if we look in the top down here, at default, 12 noon here, it's a little too early in the day, so we'll click that through a few hours at 4 o'clock now. That may be more what we're looking for. It hasn't totally taken the turn, and you can see down here the front face of these buildings are in shadow still, and the right side is illuminated, so it hasn't quite taken the turn. If we go much further, we might start to get light on those front faces, so I think 4 o'clock would be good. And then from here, we just want to dial in our camera exposure settings on the V-Ray camera. So I'm going to unhide the rest of the buildings. Just going to hide the context for now. And before I do this, so if we want to check exactly about the shadows, sometimes it's helpful to compare where the CG shadows are lying on top of the footage. And we can do that if we add our viewport background into the environment slot and have it render behind the 3D. So I'm going to do that real quick. Again, just load in a sequence into a bitmap node. And then you just want to dump that into, actually, I'm going to copy this V-Ray sky because we're going to need that in a minute. Now our footage is in the environment slot. We do need to offset it because our start frame is not at 0. So we'll do that same 2761 offset so it now will start at the same time as the viewport. So now that I have that set up, I'm actually going to turn it off real quick, but we have it set up. We can drop it in again. I'm going to get the exposure dialed in first. And usually we'll just use like a white override material. I don't know. I like using 165 for no reason, but that seems to give a good white value, that white, light gray value that will match a lot of tones in your scene. You don't want to go to 255 because that will be, well, if you're working in a linear workflow, which we typically do, if you go to 255 white, it's going to be way too blown out. So typically you don't want to go much higher than 190, 200 on the whites. But we'll start that a little, or keep that a little lower. So I'm going to drop that into the override material and just check some render settings. Just dumb it down a little bit. This will be a test with V-Ray 3. Haven't used it yet, so see how it goes. Looks like a lot of the same settings, but
If you're missing anything, if you hit basic,
yeah.
you can shift it to more advanced modes, and it'll bring back the rest of the settings.
Oh, okay.
It's just a way to clean up.
Okay. All right, so do a test render here. So one thing that we will be looking for here is, since we still have the V-Ray sky in the environment, we can at least use that as a base to determine if the exposure is right, because we can see the sky in the footage. Then we're also looking at the white values on that override to see if they're matching roughly what's in the scene. And then lastly is the shadows, the way they're falling and cast on the buildings, to see if they match what's in the footage as well. So one thing I wanted to do, which I didn't here, is turn that plane back on and actually just use it to catch some shadows. So if you go into the V-Ray properties on an object and check a few things here. So matte object will use it as a matte object and cut other pieces of geometry behind it out. by default, it will still be in the alpha, so you have to change the alpha contribution to -1, and now it will cut a hole in the alpha as well as matting it out. We also want it to, you're still able to catch shadows with it, even if it's not visible, so we can check that on, and then effect alpha will put those shadows as the alpha channel for that object. So those 4 things: matte object, -1 alpha, shadows, and effect alpha. Hit close there. So now if we render this again, just duplicate it. So you'll see in the, is that anything to worry about, Jeff? Okay, so you notice in the RGB pass, you see the shadow under the buildings. If you go into alpha, you'll see how that's working. So the buildings, if you hover over, are 1 in the alpha, but if you go down into the shadows, you notice that the value is a little lower, so which makes sense because the shadows aren't going to be pure black on your scene. So by doing that, question? So if, say, there was a lake right in front of the buildings, and you wanted to catch the reflection of the buildings into the water? One second. All right. You just change one V-Ray setting here. Looks like our rendering is killing the recording, so I turn that priority down. Okay, so let's assume that this plane, we want to catch some reflections in. If I just make a quick water material, good enough, and apply that to the plane. With those same matte properties that we checked, if I render this again, see, did it do it? Not catching it.
Because the material's being overridden.
Good call. Got to exclude it from the override. Plane 92. That is. So it was applying the white material to the plane, thus it didn't get any of the water material and the reflections that it needed. So hopefully this will fix that. We're getting there. So since we set those matte properties, it's still going to cut out the object as a whole from the alpha, but it's still going to catch the shadows and the reflections if the material had reflective properties. So you can see the darker blue is where the shadow is, and then this lighter reflection is where that would be. It might get a little tricky if you wanted to separate where the reflections and the shadows were, but if you're trying to composite it back in, this may be enough with some mattes to select the pieces, but this is how we typically set up our animated, like people in car passes and things like that, where they might be reflected in glass or even behind glass, or walking along water that would need to be reflected. So you're still able to matte out the whole scene and just get a pass of what you want, but you can still catch the shadows and reflections with that pass. And I can show you real quick. If you guys use V-Ray, you probably use the multi-matte element. We use that a lot here. It just allows you to assign through the object ID a matte channel. So if we select all the geometry, and go into the object properties, just the general object properties, and notice the gbuffer object ID. So this is the value that you set in the multi-matte element. So it can be whatever you want. Just set it to 20. And then in the multi-matte element, we'll set, in each multi-matte element, you can create as many as you want, but in each one you get 3 channels are red, green, and blue. So we're just going to need one channel for this. Just turn on one of them. Doesn't matter. You can set it to the red. We'll do that here. And then that same number, the object ID, you'll put here. So when we render this again, in your element pass that should come out here, it's going to have the whatever you set that object ID to that same channel, and you still get that alpha information, but a little later on today in the animated build class, I'll show you, once you get this into After Effects, how to split out the channels. And you can use this red matte to cut out the buildings here, leaving just the shadows and reflections, so then you can treat them differently in post. So just to wrap up the camera exposure, I mean, it's pretty close. You can see how the shadows are falling on the ground. I think it's probably good enough, and even the exposure looks decent. I mean, in the horizon, you're starting to get some of the blue tones. It's not going to be perfect. You can always, fine-tune it in post, but you just wanted to get in the right ballpark. If anything, it might be getting a little too blown out even. Even with that 165 white, we're still clipping a little bit, so we may want to just turn the exposure down a little bit, and that's something we'll typically do. Most of the time is render it a little underexposed, so you can correct it back in post. You can also save unclamped out of V-Ray, so you'll get higher than 1 values, but we typically try to keep it under 1. So for this, I might just change the f-stop a little bit up to expose it down a little bit. But we don't need to go through any of that right now. I was going to move on to another example unless there are any more questions here. Got one in the back.
Thank you. I just wanted to ask you, because you were talking about the exposure of the image that, probably, the upper part and the side look the same. What format do you use for animations when you're for the RGB frame?
So just all the passes out of
No, what I
Mac?
was saying, do you save it as JPEG, PNG,
Okay.
GGA, or AXR?
So we'll typically use 16-bit EXRs
Okay.
out of Max. We'll keep compression turned on the EXR. It will save it down pretty small with compression on. This is the EXR dialog, so 16-bit half float is more than enough information for what we need. RGBA by default. And then compression, we just use the zip compression. It's not actually changing any of the pixels, it's just compressing it so it's smaller on disk. Obviously, once you bring it into a compositing package, it may take a slightly longer time to load it back up because it's uncompressing it, but the savings for the file size are going to be probably worth it. And with that, I think it compresses black pixels down to 0. So you can get file sizes that are pretty small even for HD stuff. And having that higher range than just 8-bit to work with.
And what do you use for the elements?
For the elements?
Yeah.
We use the same.
Okay.
Yeah, typically use the same.
We use a render management system here called Deadline, and we have run into some issues in the past when you change settings in between individual elements that it was causing some problems there because it does some things to auto-create like paths and file settings based off your actual mainframes. So we typically set it just for the mainframe and then leave it everywhere else. And it'll go through and auto-generate those settings. And we haven't found it to be too much of a problem. We did some tests a while back with some different file formats. We found this to be, for what you were getting, the file size was not killing you in terms of rendering those out as 8-bit TIFFs or something like that. So we just came to the conclusion that it was better to keep it one standard across the board rather than change it individually in between each one.
And a lot of time with the element passes, unlike the beauty pass where it's mostly every pixel is some color, a lot of the element passes have a lot of more black pixels. So with the compression on in the XR, some of those element passes could be pretty small, even well under a meg, probably even a few hundred kilobytes, even though they are 16-bit EXRs. So just to kind of close the loop on this shot before moving on, I'll just show you real quick the final shot of this aerial clip. Obviously, a lot more went into it in compositing and integration, but
I think actually Carlos might talk to that a little bit tomorrow. Yeah.
Okay. I think you're right. This will be on into the compositing and aerial footage integration. So. Oh, you might have to wait until tomorrow for that. We don't want to give it all away. But all right, I'll answer that one. So we had, it's not the exact buildings, but we just had, a bunch of random houses and trees and just site elements that we populated basically on this whole side of the road. All of these houses and neighborhoods and parks, we just put stuff there. Not exactly what's there, but just, things that had the general shape and general colors and textures. So just to pick something up. So you do get it in all the the glass up front there.
We've also done a couple other projects recently where we just took some photography and stitched it together and made one big kind of curved card and just set it off in the distance and made it large enough so that none of the edges were being seen in those reflections, and that worked fine for a bunch of shots.
You use the plane to remove photo to produce the global illumination over the building?
Yeah, most of the time we'll have something on the ground plane. You could obviously have a V-Ray plane with it's good to have something on the ground plane, but even though it's not going to be visible to the camera, but just to get some global illumination, it's good to have, you kind of get two uses out of it. You can use it to align the site or to get the right rotation, and then have it there for GI bounce, or even you could get some reflections from it, but it may not be ideal because it is flat. If we were to do that, we might piece together a little higher res map, taking multiple screen grabs and stitching it together to get a little more detail, but we'll usually have some reference, and at least in the immediate site, like across the street here, we'll have actual geometry, even though it's not visible. And I think for this case, this building, the white building right here, is the one from the actual footage, the one that's existing. So we used the massing to mat out the CG behind it, so you could cut the footage back on top. But I think they'll show that in a little more detail tomorrow. So the final thing I wanted to show on the tracking and integration side of things was if you want to bring the 3D data back into another compositing application like After Effects. So I'm going to open up a different scene for that.
There's a question online here. It says here, do you use video filter or area filter in V-Ray when rendering animation, and what is the value you use for it? What's the camera setting for animation do you use as well?
Yeah, for animations, we'll use the area filter, 1 or 1.5. For stills is a different story, but the animations typically will have that anti-aliasing filter on, just to smooth things out a little bit. And what was the second part, Jeff?
What's the camera setting for animation that you use? And then the other one was, do you use the video filter or the area filter in V-Ray when rendering animation? And what value do you use for that?
So, not totally sure about the camera question, but if it's what I think it is, we use the still camera, the still V-Ray camera. We don't change it to the video camera, just because of the way the exposure settings are active in the still camera. You get the normal f-stop and shutter speed and ISO values. When you switch it to the film or the video camera, it grays out some of those. So we like to keep, we do a lot of shooting on DSLRs for video. So with that, you still have the same exposure settings. So we try to keep that pretty consistent. But I don't think it really matters what V-Ray camera setting you have for animation. It's just how many of those settings you want access to.
Rendering animation, it tends to flicker a lot because of which, depending on which filter do you use. What you prefer to use?
For the global illumination?
No, the AA. Do you use QMC?
Yeah, let me be a little easier to speak to that when I have the settings up, but once this file loads, I can open that up. So while this is loading, I'll just show you the shot that I'm opening here. So this was a shot we got from the harbor, just outside a little bit. So we were actually out for a different project, and a few piers down, and we thought, well, while we're out there, we might as well get the site for this project. It'd be cool to see it from this angle. We had mocked some things up in all CG for this, but if we could get a video backplate to use, we thought that would be pretty impactful. So this was shot just with I think we had our red camera, probably on a tripod, but still on the boat, so it's a little shaky. And actually didn't take out any of the stabilization, or didn't stabilize it at all. Thought the shakiness wasn't too bad, that it was cool to keep in. So our building is the blue one in the foreground, and this is also a CG building, but the rest is the footage. So looks like that loaded here. So I already have the track data brought into this file. I'm just going to show you a couple things to how to use that 3D data out in After Effects. So this was not a final version of the shot that I just showed you. And if I open it again, you'll notice a few things here that are not perfect. Mostly the cranes in the back left. I have a frame of this. Without the CG, you'll see it a little better. So our building is going in front of this building, so we don't have to worry about that crane. But over on the left here, we do see a bit of this building, and there's some cranes and equipment in there, which you see peeking through just a little bit. So I'm going to go through how we can clean that up with the 3D track data in After Effects, and also to this front stone kind of feature. Our site kind of lines up on top, but it's cutting in a little bit, and it'd be nice to bring back some of those rocks out in front again. So I'll show you how to do that too. So the first thing, if I just turn on, maybe it is already on the footage. Yeah. So I actually can turn off the geometry. Turn the camera data back on. So what we want to do is pick some points that stick to a real world point that we can export and then draft off of in After Effects. So I'll start off by grabbing a few on the stones here. And sometimes it's hard to tell in one view if it's actually there or if it's behind it somehow. But if you just scrub through, just make sure it's sticking to where you think it should stick. And then I'm also going to grab a point or two on the building in the back left that the cranes go in front of. So looks like that point sticks pretty well. So this is a little obsolete now that they have the direct max to AE linking, but we have a couple scripts that we wrote a while ago. Before that, linking was there to help us out with this exporting of data. So I think Nils and I wrote this several years ago now, but it goes through and basically creates a Maya ASCII file from scratch with all the camera and helper information, and then you're able to bring MA files into After Effects as 3D information. So I'm not going to go through this code. You know, like I said, we can supply some scripts after, so we can include this in there, but I'll just launch it. So it has all your cameras in the scene. You just pick whichever camera you want exported, and then you have to capture a helper selection. So whatever helpers you have selected, you can capture that, and it's only going to export those. So if we go to export scene, just put it on the desktop for now, but and save out that Maya file. And if I jump into After Effects, I have a file set up with, just has 2 layers, the backplate footage and the CG that was rendered. So you can see what the CG pass was without any of the final kind of compositing magic on it, but you can see those cranes are still in the back left, and the site is kind of cutting over the rocks. So we can import that that Maya file in.
Desktop, right?
Yeah. These I already exported earlier. So I have two Maya files that I exported earlier just to have them. So if you open one of them up, so basically it creates a comp for each file. And if I open that, you'll see that there's nulls that correspond to the dummy points that you export from Max, and then a camera. And then on those objects are keyframes, every frame, just the way it had to be done here. We'll keep the keyframes on the camera because it's moving, but the dummies don't move, so we can kill those keyframes. The reason we had it was if you wanted to export moving helpers to bring into After Effects to do other compositing, you know, linking particles to them or what have you, but we don't need them here. So if I just scrub through, so that's another thing. You notice that here it's not doing anything. It exports the whole frame range all the way up to the end. So our kind of area of interest was only 2700 and up. So that's all we really need. But it's good to have the whole range just to align it to the rest of the footage. So if I copy the nulls and the camera and go back into our comp here and paste it on in this range. Actually, I'll turn off the CG. So you'll see that those points stick pretty well to that building in the background. I already went in and created a clean texture of that facade. It's just this piece, just clone stamped, patched together in Photoshop. But you can create whatever patch you need. So I'm going to bring that into the comp here. First thing I'm going to do is reset the pivot point to a corner. It's a common theme we've seen so far, and talk about it more later, but having the pivot points in the corner or edges of things make makes your life a lot easier than having it in the middle, and then once you move and scale, you're going to have to, or rotate and scale, you're going to have to translate it back. So if you can lock down one corner in the position that it is, then you can only have to worry about the other two variables. So reset the pivot to the corner, and then actually turn it into a 3D layer. It's going to throw it off into space somewhere. That's okay. We can highlight the point that we want to link it to, and copy the position track and paste that onto our patch. So it will align that position, and then from there you can just rotate things up. What are we doing? It's always a guessing game with this. We are not right. There we go. We'll just make these numbers a little nicer. So our corners stick, so if we scrub through, we'll notice that that patch is in 3D space, covering up that corner of the building, but we want to scale it up a little. And I've made this patch way too big. I kind of forgot how much of the cranes blocked it when I was putting it together, so I just got more than we need. I'm going to drop it down a little, and then from here, you can kind of just mask it off roughly what you need. Maybe it'd be better to draw a straight line on one of the floors just to have it be a little nicer. So you'll fine-tune it a little here, just making sure the windows and everything line up, but actually sometimes you even need to scale it non-uniformly, so in this case we might want to scale it up just in the Y. But you know, it's just eyeballing it, getting a rough match. This isn't perfect. I'm not going to spend more time on it, but with that there, then you can put the CG back on top, and I turn that patch on and off. That frame don't see a lot, but this frame, you can see how it's covering that up. So little things like that, once you have the 3D track data, you can definitely leverage it more than just rendering the main part of the site into the scene. You can use it to patch things out, or, you know, as you'll see tomorrow, putting in motion graphics and green screen people into 3D space as well in post. So I won't go through the process here, but I exported the nulls for the wall, so you could do the same thing to cut the footage back on top and put it on top of the CG.
If you wanted to add the reflection of the building on the water,
yep.
Right now, well, would you use an animated map for the bump so that it would come also with the waves of the water? And also, how would you create the reflection so that it's also dark and blends with your natural reflections from the plate?
So a couple things with this. Because there's a building right behind it, you're already getting a reflection from this building in there, so I mean, whatever you do is going to be a little bit of a hack. So you could put the new reflection on top of it, but it's already dark here, so depending on how crazy you want to get, you may even patch this whole section of water and then put the new reflection on top. But for this, we would probably just, you know, with the method we showed earlier with that plane that caught the reflection, you'd set that up in Max, have a plane that is not at the bottom of the building, but 4 or 5 feet lower to match the bottom of the wall, with a massing of the wall to mat it out, and then using the V-Ray mat properties we showed a little while ago, and a water material applied to that to catch the reflection of the building. And then for this, we'd probably do it as a separate pass just to have better control over it. But then it's just a matter of, tweaking the color in After Effects, trying to match it. As far as the animated bump or the noise, you could do it either way. I'd probably keep it as a static bump out of Max. You still want some bump and some glossiness to the reflection to roughly match the water, but then in After Effects you can use like the fractal noise and the turbulent displace effect to have better control over the animated nature, so it will kind of evolve it over time. It's kind of personal preference. You could set up an animated bump in Max and render that out, but once you render it out and you find out it's too fast or too slow, then you have to render it again. Whereas this way you have the control live in After Effects, and then you can just tweak it there. Any other questions? One up front, Jeff.
Just to follow up on that reflection question, would you replace the entire water, or would you just blend it into the existing water a little bit?
In this case, probably blend it into the water, just because, one, it's so close in the foreground that you want it to look as real as possible, and also most of the existing buildings are reflecting in already, that you probably want to try to preserve that. So if anything, you might patch out the old reflection just in this section with kind of clean water or non-reflective water, but I feel like that would get too messy. We'd probably just try to patch it on top, but the nature of this water, you see this lighter part here because in the original footage you see the sky come out, but once you put the buildings in there, kind of makes a solid wall of buildings, so it's going to be pretty dark and muddy throughout the whole front, so that may actually help us in kind of just blend it all together. If it was the only building that you're adding in, then you may pay a little more attention, and in that case you may want to do a full water replacement, but since there's so much going on here, it probably makes more sense just to blend it. Any other questions? All right. I think we're done for now. Oh, one more.
If you were to, okay, so let's say for a different type of footage where the camera is looking up and it's in movement, and you have a glass building that reflects. So usually you would see the animation of the reflection, which will come from the dome. But in most of the cases, if the camera is moving, like that's the one area that starts to look kind of fake, the reflection on the building, and that's because everything that is reflecting comes from the dome, which is far away in the distance. So we've tried to map different geometry that are at different levels, creating kind of layers for that reflection. But I don't know if there's a better way, an easier way, or how would you deal with that?
I think we would do the same thing. If I open up that the example again we had up earlier, reflections in the glass on these buildings. We did have some 2D maps that obviously whatever's mapped to it are going to be the same distance away on the card, whether it's a card or a dome. But we had the other 3D geometry at different levels to reflect, and then once the camera's rotating around, we're not getting that close to this, so you can't see that well, but you would notice that geometry is at different levels. So, I mean, you're absolutely right. If you just have one dome that has an image and it's mapped with something, the reflections are going to look weird. So, yeah, I think it's just the way it is. You do have to build those layers in. Hopefully, you don't have to build the whole site, and it's more just a focused area that you see in that shot. But depending on how close you get to the building, you may need to spend a little more time with it. Break for now.
Okay, let's take a quick 5-minute break. So just we're right at 3 o'clock now, so let's do 3:05 back sharp, and then we'll start up right away.